Hello there, and welcome to Soft Mystic Stories, where curiosity slows its breathing, questions soften their edges, and science takes the long, quiet way toward rest. This is a place for wondering without urgency, for thinking without needing answers right away, and for letting ideas drift past like clouds rather than demands. Tonight's journey begins with a thought that feels simple at first, almost playful, but grows heavier the longer it's held. It's the kind of idea that sits quietly in the background of your mind and only speaks up when the world goes still. The question is this: what if the world we're living on now is not the first world of its kind? What if Earth is not a fresh beginning, but a place that was already here, already shaped, already altered before anyone like us ever arrived? At first, that might sound like science fiction, the sort of idea that belongs in old paperbacks or late-night movies with dramatic music. But stay with it gently. No rush. Imagine the planet beneath you not as a blank slate, but as a surface that has been used before, quietly, thoroughly, and then left behind. Like moving into a house where the previous occupants took everything they need. Ed cleaned carefully and locked the door without leaving a note. No broken furniture, no obvious mess, just the faint sense that things have happened here before, and that whatever those things were, they are no longer part of the daily noise. Before we go any further, let me ask you something simple. Where are you listening from right now? A bedroom, perhaps? A couch? Maybe a place halfway between sleep and attention? And what time is it where you are? Not because the number matters, but because it anchors you to this moment. A conversation about forgotten worlds feels different depending on whether it's early evening, deep night, or the quiet edge of morning. If you're finding this idea calming rather than unsettling, or if it feels like a gentle place to rest your thoughts for a while, you're very welcome here. And if you'd like to help this calm corner reach others who enjoy slow science and quiet curiosity, a like or a subscription is always appreciated. Now, without any sharp turns, let's begin easing into the idea itself. Most of us grow up with a very specific story about Earth. It's ancient, yes, but empty in a certain way. Rocks formed, oceans cooled, life began slowly, cell by cell. Over billions of years, dinosaurs arrived, left, mammals took over, and eventually humans appeared, blinking into consciousness, naming things, building cities, and asking questions. In this story, we are late, but we're first. The planet belonged to bacteria, to plants, to animals, but never to a thinking technological civilization before us. Earth, according to this view, is old, but untouched by minds like ours until recently. Now, imagine adjusting that story slightly, not rewriting it completely, not adding dramatic alien monuments or glowing machines, just shifting one assumption. Suppose there was a civilization here long before humans, not millions of years ago in the age of dinosaurs, but perhaps hundreds of millions, or even billions of years ago, when Earth itself looked different. Different continents, different atmosphere, different chemistry. A civilization that rose, used the planet, altered it in subtle ways, and then disappeared. Not destroyed in a fiery catastrophe necessarily, but ended through a long process. Migration, transformation, leaving, or perhaps simply fading into forms we would no longer recognize as technological. The first reaction to this idea is usually skepticism. Surely, we would have found something by now, a tool, a structure, a signal. But that reaction assumes that evidence always looks like what we expect evidence to look like. It assumes that intelligence leaves behind pyramids, metal objects, written records, or debris that survives untouched for hundreds of millions of years. When you think about how quickly our own structures decay without maintenance, that assumption becomes less certain. Concrete cracks, steel rusts, plastics break down under sunlight. Even our most durable cities would be swallowed by geology in a surprisingly short span of deep time. Consider this. The oldest visible human-made structures on Earth are only a few thousand years old. Even stone erodes. Even mountains disappear given enough time. Plate tectonics recycle the crust. Oceans dissolve and redistribute materials. Volcanoes reset landscapes entirely. The planet is not a museum. It's an active system that grinds, melts, compresses, and reworks its surface constantly. If a civilization existed hundreds of millions of years ago, it would not need to hide its traces. Earth would do that work automatically. Think about what would remain of our own civilization if humans vanished tomorrow and Earth continued on without us for 100 million years. Satellites would fall, buildings would collapse, roads would crack, then vanish beneath soil. Metals would oxidize, disperse, and sink. Nuclear waste might leave a faint chemical signature, but even that would blur with time. The continents themselves would shift. New mountains would rise, old oceans would close. After long enough, the surface would appear natural again, shaped by wind, water, and life, not cities. This is where the idea begins to feel less impossible and more quietly unsettling. If Earth had hosted a previous civilization, it wouldn't leave behind a clear message. It wouldn't announce itself with a sign that says, "We were here first." It would leave behind subtle changes, slight imbalances, patterns that look natural, unless you know exactly what you're looking for. And even then, interpretation would be uncertain. Now, let's slow this down a little. The idea is not that humans are living among ruins we simply haven't noticed, not buried cities under forests or oceans filled with machines. That kind of story depends on recognizable leftovers. Instead, imagine a civilization whose technology was based on principles we don't use. Materials that integrate into ecosystems, energy systems that don't leave massive waste, structures that dissolve, biodegrade, or are deliberately removed. If such a civilization valued long-term planetary stability, its goal might have been to leave as little trace as possible. It's worth noticing how our own thinking has begun to drift in that direction. We talk about sustainable materials, circular economies, technologies that leave minimal footprint. If humanity survives long enough, our later tools may be quieter, cleaner, and less obvious in the geological record than our early industrial scars. A far older civilization might have reached that stage long before disappearing. There's also the matter of time scales. Human history feels long to us because our lives are short. 1,000 years feels enormous. 10,000 feels almost incomprehensible. But Earth's history is measured in billions of years. On that scale, even an advanced civilization that lasted millions of years would be a brief event, a blink, a layer of paint quickly covered by new coats. So, where would we even look for evidence? The answer might not be objects, but anomalies, strange concentrations of certain elements, unexplained shifts in atmospheric chemistry, isotopic ratios that don't quite match purely natural processes, long-term changes in climate patterns that can't be fully explained by known mechanisms, not proof, but hints, whispers, rather than declarations. Some scientists have actually considered this idea seriously, not as speculation about aliens, but as a thought experiment. It's sometimes called the Celeron hypothesis, named not because it involves reptiles from a television show, but because it asks whether an industrial civilization could exist in Earth's deep past without leaving obvious traces. The conclusion is not that such a civilization definitely existed, but that it's harder than we think to rule it out entirely. That doesn't mean the idea is true. It means it's not as easily dismissed as our instincts suggest, and that's an important difference. Science often advances not by proving bold ideas, but by noticing where certainty weakens. Now, pause here for a moment. You don't need to decide whether you believe this. You don't need to argue for or against it. Just Let it sit. The idea of Earth as a place that has been used before, shaped before, then handed forward through time, not by intention, but by physics and geology. If such a civilization existed, it would not have known us. It would not have prepared the world for humans. Any compatibility would be accidental. And yet, here we are breathing this atmosphere, drinking this water, using metals concentrated in Earth's crust, living off an energy-rich planet that seems almost suspiciously well suited for technological life. That suitability is usually explained by natural processes, and those explanations are strong. But the thought lingers. Could some aspects of Earth's current state be inherited? Not designed for us, but left behind nonetheless. Think about abandoned infrastructure in human terms. When a city is left behind, nature doesn't immediately erase it. Plants grow through cracks. Animals move in. Water flows differently. The land changes, but traces remain for a while. Now stretch that image across deep time. Replace buildings with planetary systems. Replace years with eons. What remains might not look like ruins. It might look like nature doing what it does, just starting from a slightly altered baseline. There's also a psychological layer to this idea. Humans like firsts. We like origin stories, where we are the main characters. The thought that we might be the second intelligent civilization on this planet or the third unsettles that narrative. It makes us less special, but also less alone in time. It suggests that intelligence is not a miracle but a phase Earth may enter more than once. That possibility carries a quiet responsibility. If others came before and are gone now, the question becomes why, not in a dramatic sense, but in a practical one. Did they leave voluntarily? Did they collapse? Did they merge with something else? Or did the planet simply move on without them, as it always does? None of these questions demand answers tonight. They don't need resolution to be meaningful. The value here is not in proving a forgotten civilization existed, but in what the idea does to how we see our place. It nudges us to think longer term, to imagine Earth not as our possession, but as a system that hosts intelligence temporarily. As you settle into this thought, notice how it changes the feeling of being here. The ground beneath you becomes older in a different way, not just ancient rock, but a stage that may have been used before. The sky above becomes less of a boundary and more of a ceiling that has watched many versions of life come and go. And as this idea continues to unfold, it naturally leads to another question, one that doesn't yet need words. If Earth could forget a civilization once, what would forgetting look like? Sometimes an idea doesn't arrive loudly. It doesn't announce itself or demand attention. Instead, it shows up quietly, sits in the corner of your mind, and refuses to leave. You don't remember when you first noticed it, only that once it's there, it keeps resurfacing at odd moments. While looking at a satellite image of Earth, while reading about ancient rocks, while staring at a landscape that feels older than memory, the thought that lingers is simple, almost stubborn. What if this world has been used before? That idea tends to come back precisely because it doesn't rely on spectacle. There's no need for dramatic ruins, glowing relics, or lost machines humming beneath the ground. It survives because it fits too comfortably with what we already know about time, geology, and how easily evidence disappears when no one is left to maintain it. The longer you think about Earth's history, the more that quiet possibility presses in. Not as a claim, not as a theory demanding belief, but as a question that keeps reopening itself. One reason this thought refuses to stay buried is scale. Human intuition struggles with deep time. We can imagine centuries, perhaps a few thousand years, but millions begin to blur and billions turn abstract. Yet, Earth has been reshaping itself for over 4 billion years. Continents collide and separate. Oceans open and close. Entire mountain ranges rise and vanish. Life itself has nearly been wiped out more than once and rebuilt from what survived. Against that backdrop, a technologically capable civilization lasting even 1 million years would leave only a faint imprint, if any, especially if its peak came and went long before humans ever appeared. Another reason the idea persists is that it doesn't conflict with known science as much as it seems to at first glance. It doesn't require rewriting biology, physics, or chemistry. It doesn't need faster-than-light travel or supernatural intervention. It only requires one assumption that intelligence under the right conditions might arise more, rather than once on the same planet, separated by spans of time so large that continuity becomes impossible. Once that assumption is allowed to exist, even tentatively, the rest follows naturally. Civilizations are processes, not permanent states. They depend on energy flows, stable environments, and the ability to adapt. If those conditions change, civilization change with them, or disappear. Earth has never been static. Its climate has swung wildly. Its atmosphere has shifted composition. Its surface has been repeatedly reworked. A civilization adapted to one version of Earth might find itself incompatible with another. This leads to an uncomfortable realization. We often assume that if something important had happened before us, we would know about it. That assumption is rooted in our experience with human history, where written records, oral traditions, and physical artifacts connect generations. But that chain only works over short spans of time. Beyond a certain point, continuity breaks. Languages vanish, cultures dissolve, records decay. Push that far enough back, and even memory itself is erased. Geology is not sentimental. It doesn't preserve stories. It compresses, melts, fractures, urges, and recycles. Sedimentary layers are overwritten. Tectonic plates dive back into the mantle. What survives does so by chance, not by importance. Fossils exist because conditions happen to be right, not because the organisms were significant. If we apply that same logic to intelligence, there's no reason to expect it to be preserved any more carefully than if anything else. The thought becomes harder to dismiss when you consider how selective the geological record already is. We know far more about some periods of Earth's past than others, not because those periods were more important, but because the rocks survived. Entire chapters of planetary history are missing, subducted, eroded, or buried beyond reach. If something unusual occurred during one of those missing intervals, we might never know. This doesn't mean the idea is true. It means the absence of evidence is less decisive than it feels. There's a difference between we see no sign and no sign could exist. The thought lingers in that gap. There's also a psychological reason this idea keeps returning. Humans are pattern-seeking creatures. We notice cycles. We see rise and decline everywhere from ecosystems to empires. Vilifications grow, peak, fragment, and fall. Species appear, spread, and go extinct. Stars ignite, burn steadily, and eventually fade. Against that pattern-heavy backdrop, the idea that intelligence appears once and never again on a planet that remains habitable for billions of years feels oddly asymmetrical. Earth has supported life for an astonishingly long time. For most of that history, life was simple. But once complexity began accelerating, it did so repeatedly. Multicellular organisms emerged more than once. Eyes evolved independently in different lineages. Flight appeared in insects, birds, and mammals separately. Intelligence, at least in problem-solving forms, has shown up in birds, mammals, and cephalopods. If cognitive complexity is not a singular accident, then the possibility of technological intelligence appearing more than once becomes hard to ignore. The lingering question isn't why such a civilization must have existed, but why we assume it couldn't have. Often the answer is emotional rather than logical. We're used to thinking of ourselves as the beginning of something unprecedented. It gives meaning to our achievements and weight to our responsibilities. The idea that we might be inheriting a world already shaped by another intelligence challenges that narrative. It suggests that intelligence is not the climax of Earth's story, but a recurring phase. That idea can feel diminishing at first, but it can also be grounding. If others came before and are gone now, it places us within a much longer arc. It reframes our technologies not as endpoints, but as temporary expressions of what a planet can produce under certain conditions. This thought also persists because it changes how we interpret what we already see. Geological oddities, unexplained transitions, and abrupt shifts in Earth's systems take on a different tone when viewed through this lens, not as evidence, but as questions. For example, Earth's climate history includes periods of rapid change that are still not fully understood. Most have plausible natural explanations, and many are well accounted for, but the existence of unknowns keeps the door open just slightly. Similarly, the distribution of certain elements in Earth's crust reflects processes we largely understand. But industrial activity, even over relatively short spans, can alter those distributions measurably. If a civilization, Tion, had industrialized and then vanished long ago, its signature might be subtle, diluted, or misattributed to natural variation, not hidden intentionally, simply blurred by time. The idea also refuses to disappear because it highlights a blind spot in how we define evidence. We tend to look for things that resemble us. Cities, tools, structures, energy use patterns we recognize, but an intelligence that developed under different constraints might leave behind very different traces. Its technology might not rely on metals in the same way. Its energy systems might not concentrate waste. Its materials might integrate into biological cycles rather than resist them. Even our own technology is shifting in that direction. We're beginning to design systems that leave less residue, generate less long-term waste, and dissolve back into natural processes. If humanity survives long enough, our later footprint may be quieter than our early industrial scars. Looking far enough ahead, our most advanced technologies might be almost invisible in the geological record. That realization strengthens the original thought. If advanced technology can become less detectable over time, then detectability is not a reliable measure of existence. Silence does not necessarily mean absence. Another reason the idea keeps resurfacing is that it doesn't require aliens. It doesn't depend on visitors from other stars or improbable coincidences. It's a purely Earth-based speculation. The same planet, the same chemistry, the same long timeline that makes it feel closer, more intimate, and harder to wave away. When people hear this idea for the first time, they often ask why such a civilization wouldn't leave behind fossils of itself. But that question assumes that intelligent beings would resemble large animals with durable skeletons. Intelligence does not require bones. It does not require bodies that fossilize well. Even among Earth's current life forms, some of the most cognitively complex creatures leave poor fossil records. Soft bodies, small sizes, or unusual compositions vanish quickly after death. There's also the possibility that intelligence took a form we wouldn't immediately classify as such. A distributed system, a symbiosis, a species that altered its environment through biochemical processes rather than construction. If intelligence is defined strictly by our own example, we need to be careful not to confuse it with our own example. Row the field dramatically. If it's defined by the ability to manipulate environments and solve problems collectively, the field widens. This line of thought can feel unsettling, but it's not inherently threatening. It doesn't imply danger or superiority. It implies continuity. Earth is a stage that hosts different players at different times, each constrained by the same physical laws, each temporary. The persistence of this idea also comes from how it reframes the future. If Earth has hosted intelligence before and moved on, then the planet does not depend on us. It will continue reshaping itself regardless of what we do. That doesn't make our actions meaningless. It makes them contextual. It places responsibility not in permanence, but in stewardship during our window of influence. And there's something quietly humbling in that. We are not the first, and we will not be the last. Even if we are the only ones we know about, that doesn't lessen the value of what we build or discover. It situates it within a longer story that doesn't revolve around any single species. The thought also lingers because it aligns with a growing awareness of fragility. We are beginning to understand how the dependent civilization is on narrow environmental conditions, stable climate ranges, reliable energy flows, predictable ecosystems. If those conditions shift too far, complexity becomes harder to maintain. A previous civilization might not have failed dramatically. It might have simply become unsustainable under changing conditions and gradually dissolved. In that sense, disappearance doesn't require catastrophe. It can happen quietly through adaptation in the wrong direction, loss of complexity or transformation into something no longer recognizable as a technological society. The absence of ruins might reflect not destruction, but transition. As this idea continues to circle back, it naturally pushes attention toward the concept of inheritance. Not inheritance in a genetic sense, but planetary inheritance. We inherit atmospheric composition shaped by ancient life. We inherit soils formed over millions of years. We inherit fossil fuels created from organisms that lived long before mammals existed. Whether or not intelligence existed before us, we're already living off the deep past. That alone is enough to make the idea feel less strange. We're already beneficiaries of previous eras. Adding the possibility of a forgotten civilization simply extends that logic. The thought doesn't insist on belief. It doesn't demand agreement. It stays because it's compatible with uncertainty. It leaves room for not knowing. In science, that's often where the most durable questions live. As you sit with this idea, notice that it doesn't point backward alone. It also points forward. If Earth can forget, then memory is temporary. If civilizations fade, then impact matters more than duration. The question quietly shifts from where we first to what kind of trace are we leaving now. It helps to approach this idea slowly because it's not about replacing what we know, but about reframing it slightly. Think of Earth not as a pristine starting point, but as something inherited. Not inherited deliberately, not passed down with instructions or warnings, but inherited in the way landscapes inherit rivers or forests inherit soil, shaped by roots that are long gone. A hand-me-down world is not a broken one. It's a world that has already been lived in, adjusted, and then left to continue on its own. When you move into an old house, even a well-maintained one, you can usually tell you weren't the I'm the first person there. Doors hang in a certain way because they've been opened thousands of times. Floors creak where weight has been applied again and again. Walls carry layers of paint that hide earlier colors. None of this interferes with living there, but it quietly reminds you that your presence is part of a sequence, not a beginning. Thinking of Earth this way shifts something fundamental in how we relate to it. Most of the time, we treat Earth as a natural system that ran untouched until humans arrived. In that view, we are the first agents capable of large-scale planetary change. Everything before us was biology and chemistry, blind processes unfolding without intention. That story is neat, and for the most part it works. But it also assumes that intelligence capable of altering a planet is an extremely rare event. Something that happens once, and then never again, even across billions of years of habitability. If Earth were a hand-me-down world, that assumption loosens. The planet becomes less like a blank canvas and more like a reused one. Still functional, still rich, still capable of supporting life, but not untouched. A hand-me-down doesn't have to be obvious. Most of the tea. I mean, it isn't. You don't need to find a name written on the label to know something has been used before. Subtle wear is enough. In planetary terms, wear doesn't mean damage. It means prior influence that has blended into the background. Start with the atmosphere. Earth's air is unusual, not just because it contains oxygen, which is already remarkable, but because its composition has been stable enough for complex life for a long time. That stability is often attributed to feedback loops involving life itself. Plants, microbes, oceans, and rocks interact to regulate gases. This explanation is solid and well supported, but it also shows how profoundly life can reshape a planet. Now, imagine a civilization that learned to work with those feedback systems rather than overpower them. Instead of burning resources quickly, it might have optimized slow processes. Instead of extracting aggressively, it might have cultivated long-term equilibrium. The result wouldn't be a scarred planet. It would be a planet tuned in ways that later life would simply take for granted. This is where the hand-me-down idea becomes subtle rather than dramatic. The inheritance wouldn't be gadgets or structures. That would be conditions, slightly altered baselines, a world that seems naturally generous, not because it always was, but because it was nudged that way long ago. Of course, there are strong natural explanations for Earth's habitability. Plate tectonics recycle nutrients. The magnetic field shields the surface. The moon stabilizes axial tilt. Water cycles regulate temperature. None of that needs a prior civilization. But the thought lingers because these systems don't just exist, they persist. They operate within narrow ranges that allow complexity to thrive. In human terms, a hand-me-down often fits because it was made well. A chair lasts decades because it was designed to endure use. A planet doesn't get designed, but it can be shaped. Not engineered in a simplistic sense, but influenced through long-term interaction. This brings up an uncomfortable but important distinction. Influence does not require dominance. Humans tend to associate planetary change with force. Mining, deforestation, pollution. But influence can also be cumulative and quiet. Microbes reshaped Earth's atmosphere without intention. Coral reefs alter coastlines without awareness. Over long enough timescales, SMA, all actions matter more than dramatic ones. A prior civilization, if it existed, wouldn't need to leave behind ruins to have left a legacy. It might have altered nutrient cycles. It might have affected long-term climate stability. It might have introduced or removed certain organisms, not in a way we'd recognize as deliberate, but in a way that shifted evolutionary trajectories. This is where the idea of Earth is inherited becomes less about mystery and more about continuity. We already know that Earth today is not the same Earth that existed hundreds of millions of years ago. The oxygen-rich atmosphere we rely on would have been toxic to earlier life. The continents we live on were once scattered differently. Life has repeatedly restructured the planet to suit itself. So, the real leap isn't imagining prior change. It's imagining prior intentional change that has since been naturalized, change so old and integrated that it no longer reads as artificial. That word artificial becomes tricky here. We tend to define artificial as made by humans, or at least made by intelligence like ours. But from the planet's perspective, there is no sharp line. Processes happen, energy flows, matter regarding, organizes. Intentionality doesn't leave a unique fingerprint that time respects. Over millions of years, everything gets blended. A hand-me-down world would feel exactly like this. Familiar, natural, unremarkable. That's why the idea doesn't announce itself. It hides in plain sight. There's also the matter of resources. Earth contains concentrated deposits of metals and fossil fuels that humans exploit. Fossil fuels are clearly biological in origin, the compressed remains of ancient life. Metals, however, are distributed through geological processes that concentrate them unevenly. Mining works because those concentrations exist. If a civilization existed long before us, it would have drawn from similar resource pools. Over time, that extraction could subtly alter what remains. Not enough to be obvious, but enough to affect availability. Some researchers have pointed out that if Earth had hosted an industrial civilization hundreds of millions of years ago, one of the few potential clues might be unusual depletion patterns in certain elements. Again, not proof, just another way the hand-me-down idea quietly survives scrutiny. It doesn't rely on dramatic leftovers, it relies on absence and subtle imbalance. Think about how many assumptions we make based on what we see now. We assume that current resource distributions are the result of purely natural processes. That assumption is reasonable, but it's still an assumption. Science is built on the best explanations available, not on certainty. The longer the timeline, the softer certainty becomes. There's a psychological shift that happens when you think of Earth as inherited. Ownership begins to feel temporary. The planet stops feeling like a stage built for us and starts feeling like a place we're borrowing. That perspective changes how responsibility feels. Not heavier, but broader. If this world was shaped before and then left behind, then permanence was never part of the deal. Civilizations don't own planets. They occupy them briefly. That idea can be unsettling, but it can also be grounding. It removes the pressure to be final, to be the last, to be the culmination. Instead, it frames us as caretakers during our interval, not because someone else is watching, but because the planet itself continues long after anyone intelligence is gone. A hand-me-down object often carries marks of use that tell stories, even if you don't know who used it. A worn handle suggests repetition. A smoothed edge suggests time. Earth carries those marks too, but they're written in rock layers and isotopes rather than scratches and dents. Geologists already read Earth this way. They reconstruct ancient climates, vanished oceans, extinct ecosystems. They know the planet has been many different things. Adding intelligence to that list doesn't break the method, it extends it. And yet, resistance remains. Part of it comes from fear of diminishing ourselves. If we're not first, are we less important? But importance doesn't come from being first. It comes from what happens now, from awareness, from choice. Another part of the resistance comes from how easily this idea can slide into fantasy if not handled carefully. That's why it's important to stay grounded. This is not about secret histories or hidden masters. It's about acknowledging uncertainty at scales where certainty is genuinely hard to maintain. The hand-me-down idea doesn't say this is what happened. It says this is not impossible. And in science, that distinction matters. There's also a quiet symmetry to the idea. If Earth was once left behind by another civilization, then one day it may be left behind by us. Not abandoned in a dramatic sense, but simply outgrown, changed, or rendered incompatible with whatever we become next. The planet doesn't mind being left. It continues regardless. That symmetry invites reflection rather than alarm. It asks what kind of presence we want to have while we're here, loud or quiet, extractive or integrative, temporary or transitional. A hand-me-down world also reframes discovery. Instead of searching for proof of prior intelligence in the form of artifacts, the search becomes more about understanding Earth deeply enough to notice what doesn't quite fit. Not anomalies to jump on, but patterns to question gently. It also encourages humility. We're still learning how our own actions will echo forward. Climate change, species loss, chemical pollution. These are the marks we're leaving now. Whether or not anyone ever notices them millions of years from now, they matter in the present. As this idea settles, it begins to feel less like a speculation about the past and more like a mirror. It reflects our relationship with the planet back at us. Are we treating Earth like something new and disposable, or like messing with history and future beyond us? That shift doesn't require belief in prior civilizations. It only requires acknowledging how little of Earth's story we can ever fully know. The deeper you look into the past, the more incomplete the picture becomes. Gaps widen, assumptions soften, and in those gaps, the thought remains quiet, persistent. Earth is a place that has already been lived on, shaped, and then carried forward through time, ready to host something new without ever explaining what came before. Leaving without saying goodbye doesn't usually look dramatic. In stories, departures are loud. Sirens, collapsing towers, final messages broadcast into the dark. Reality, especially over long stretches of time, is quieter than that. Things fade, systems wind down, activity slows, then stops. Long before anyone realizes something has ended, it already has. That's the kind of departure that fits best when thinking about civilizations on planetary timescales. Not extinction as a single event, but absence as a process. When people imagine a civilization disappearing, they often picture catastrophe, an asteroid, a war, a sudden environmental collapse. Those things can happen, and, in Earth's history, some of them have, but they're not required. In fact, most endings don't arrive that way. They arrive through mismatch. A society grows under one set of conditions, then those conditions drift slowly at first, almost imperceptibly. By the time the shift becomes obvious, adaptation is already difficult. Think about how dependent civilization is on stability. Agriculture requires predictable seasons. Infrastructure depends on relatively narrow temperature ranges. Energy systems assume certain baselines. Even communication networks rely on assumptions about atmospheric behavior and material durability. If those baselines shift too far, complexity becomes fragile, not instantly, but cumulatively. A civilization might respond at first with innovation, adjust crops, reinforce structures, modify systems. That works for a while, but over long periods, adaptation becomes more costly. Energy that once went into growth goes into maintenance, then into repair. Eventually, more effort is spent holding things together than moving forward. That's not collapse in a dramatic sense. It's a gradual tightening, a narrowing of possibilities. Leaving without saying goodbye could look exactly like that. Not everyone leaves at once. Some stay longer. Some adapt into different ways of living. Technology simplifies. Large-scale projects stop being maintained. Knowledge fragments. Eventually, what remains no longer resembles the civilization that once existed. From the outside, if anyone were watching, it wouldn't look like an ending. It would look like a slow change in behavior, then silence. On Earth, we already see hints of how quickly complex systems unravel without upkeep. Abandoned cities are reclaimed by plants in decades. Roads crack, metal corrodes, animals return. Given a few centuries, human presence becomes harder to spot. Given thousands of years, it becomes subtle. Given millions, it's nearly gone. Now, stretch that timeline. Imagine a civilization that existed hundreds of millions of years ago. Even if it reached a level of technological sophistication far beyond ours, its material legacy would not survive intact. The planet itself would dismantle it, not out of hostility, but through normal processes: rain, wind, heat, tectonics, biology. This reframes disappearance. It's not about failure, it's about impermanence. Nothing built to operate on short EMS scales survives deep time unchanged. Not mountains, not oceans, not even continents. Expecting a civilization to leave a permanent mark assumes it was somehow exempt from the rules that apply to everything else. There's another way civilizations might leave without saying goodbye, one that doesn't involve decline at all. Transformation. A society might change so thoroughly that it no longer registers as a civilization in the way we define one. If technology becomes embedded in biology, or if intelligence distributes itself into ecosystems, or if artificial systems replace centralized structures, the outward signs of civilization could vanish while intelligence continues in a different form. From our perspective, that would look like disappearance. No cities, no industry, no detectable signals. But the absence of those things wouldn't necessarily mean the absence of agency or awareness. It would simply mean the expression of intelligence no longer matches our expectations. Humans tend to equate civilization with density, dense populations, dense energy use, dense information flow. But density is not the only way to organize complexity. Over long periods, efficiency favors dispersion. On. Integration over concentration. Quiet systems that don't strain their environment are more stable than loud ones that do. If a prior civilization learned that lesson fully, it might have chosen to dissolve itself intentionally, not through destruction, but through redesign, scaling down, blending in, leaving behind a planet that functions without constant intervention. That would be leaving without saying goodbye by design. There's also the possibility of migration, not necessarily to other planets in a science fiction sense, but migration into different states of existence. A civilization might move underground into the oceans or into environments that don't interact much with the surface, or it might transition into forms that operate on timescales or scales we don't monitor. We already miss most of what happens on Earth. Microbial life dominates the planet by biomass and diversity, yet most of it goes unnoticed. Entire ecosystems exist below our feet in the deep ocean or inside other organisms largely invisible to daily life. If intelligence took a form that overlapped with those domains, we might never recognize it as such. Leaving without saying goodbye also fits with the how communication degrades over time. Messages decay faster than structures. Language changes. Symbols lose meaning. Even if a civilization tried to warn or inform future inhabitants, there's no guarantee the message would survive or be understood. Stone erodes, metal corrodes, digital data vanishes without power, context disappears. Think about how hard it already is to interpret ancient human symbols without continuity. Cave paintings require interpretation. Stone carvings lose their cultural context. Written languages become unreadable without translation keys. Push that gap far enough and interpretation becomes guesswork. So, the absence of a farewell message doesn't imply indifference. It implies the difficulty of speaking across time. Even we struggle to communicate reliably with our own future beyond a few centuries. Expecting a civilization to leave a clear goodbye after millions of years assumes a level of foresight and permanence that may not be realistic. There's a quiet realism to the idea that civilizations don't get endings. They get transitions, and transitions don't announce themselves. They look ordinary while they're happening. This perspective changes how we think about evidence again. Instead of asking why didn't they leave something behind, the better question becomes, why would anything survive? Survival requires conditions, preservation requires luck, and deep time is not generous with either. Geology favors simplicity. Over long periods, complexity is ground down. High-energy structures are dismantled. Low-energy configurations persist. That's true for molecules, ecosystems, and likely civilizations as well. Anything that relies on constant input eventually fades when that input stops. This makes the idea of a previous civilization's quiet departure feel less speculative and more consistent with known processes, not inevitable, but plausible. And plausibility is enough to keep the thought alive. There's also a moral neutrality to leaving without saying goodbye. It doesn't imply guilt or abandonment. It implies limitation. A civilization cannot owe an explanation to a future it cannot imagine. Responsibility has a horizon. Beyond that horizon, outcomes are governed by physics, not intention. Humans often project emotion onto these ideas. We imagine sadness, regret, or warning. But a civilization ending millions of years ago would not have known it was leaving a future species behind. It would have been responding to its own present. That realization removes drama from the idea and replaces it with continuity. The planet doesn't reset between occupants. It carries forward whatever remains useful. Life adapts, systems reorganize, the stage stays while the cast changes. Thinking this way also reframes our own trajectory. We often talk about legacy as if it's something we can control. Buildings, records, achievements. But deep time is indifferent to intention. The only legacy that reliably persists is influence on systems that continue operating. Life itself is the strongest example. Microbes altered Earth's atmosphere in ways that still matter billions of years later. They didn't do it deliberately. They did it by existing, by interacting with their environment at scale. If any civilization leaves a lasting trace, it will be through processes that integrate into planetary cycles, not through monuments. Leaving without saying goodbye could mean leaving behind a slightly altered climate trajectory, a changed balance of elements, a new evolutionary pathway nudged into existence. Those effects would not point back to air source clearly. They would simply become part of how Earth works. From the perspective of a later civilization like ours, that would feel like nature, not inheritance, just reality. There's a subtle emotional shift that happens when you accept this. The planet stops feeling like a place that waits for us. It feels like a place that continues, regardless. That doesn't diminish human significance. It contextualizes it. If others left quietly before us, then the most remarkable thing about Earth is not that it hosts intelligence, but that it keeps doing so, that it remains capable of generating complexity again after previous waves have passed. That idea leads naturally to another question. If civilizations can leave without saying goodbye, what determines how long they stay? When people imagine evidence of a lost civilization, their minds almost always go to ruins, crumbling buildings, broken machines, something recognizable, something that looks out of place against rock and soil. That expectation is shaped entirely by human experience. Our civilizations leave ruins because our materials resist nature just long enough to decay visibly. Stone blocks remain. Metal frames rust slowly. Concrete fractures but lingers. These remnants are temporary on geological scales, but permanent enough on human ones to shape our imagination. Now, remove that time scale. Stretch it until the gap between then and now is so vast that even mountains have come and gone. At that point, ruins stop making sense as an expectation. What remains, if anything remains at all, would not announce itself as artificial. It would not look like a city swallowed by jungle or a tower under the sea. It would look ordinary. It would blend in. It would be the kind of trace that only appears unusual when examined very closely, and even then, only tentatively. The most persistent traces over deep time are not objects. There are patterns, distributions, ratios, slight deviations from what would otherwise be expected. That's where the idea becomes interesting, and also where it becomes frustrating, because patterns can almost always be explained in more than one way. Consider fossils. Fossils are rare not because life was rare, but because preservation requires very specific conditions. Most organisms that have ever lived left no fossil at all. Entire ecosystems vanished without a trace. We know they exist. Ed only because something survived somewhere by chance. Intelligence, if it arose before us, would face the same problem. Unless it took a form that fossilized easily, its physical bodies might be completely absent from the record. Even if a prior civilization used tools, those tools would not necessarily survive. Metal corrodes, ceramics fracture, components degrade. Plastics, despite their reputation, break down under heat, radiation, and pressure. Over millions of years, almost everything returns to simpler states. The few things that endure do so by becoming geologically boring. They turn into minerals indistinguishable from others. That's why traces wouldn't look like ruins. Ruins require a middle ground between durability and decay. Too fragile and nothing remains. Too stable and the object becomes part of the background. Deep time erases the middle ground, so where would traces hide? One place is chemistry. Chemistry remembers things long after shapes are gone. Isotopic ratios, for example, can persist even when structures disappear. Certain industrial processes alter the balance of isotopes in ways that natural processes rarely do. On human timescales, those changes are obvious. US. On geological ones, they blur, but they don't necessarily vanish entirely. If a civilization engaged in large-scale energy use, especially involving combustion or nuclear processes, it might leave behind subtle chemical signatures. Not glowing waste or radioactive ruins, but slight anomalies in sediment layers. Tiny shifts that look like noise unless you're specifically looking for them. Even then, interpretation is difficult. Earth's history includes massive volcanic events, asteroid impacts, and biological revolutions that also alter chemistry dramatically. Distinguishing intentional change from natural catastrophe is not straightforward. Nature is capable of producing extreme signals all on its own. Another place traces could persist is biology. Life remembers more than rocks do. Genetic information carries history forward, sometimes far beyond the lifespan of individual species. Horizontal gene transfer, symbiosis, and evolutionary bottlenecks can propagate changes long after their origin is forgotten. Imagine a civilization that practiced extensive biological engineering, not in a modern laboratory sense, but through long-term ecological manipulation, encouraging certain rates, suppressing others, altering ecosystems gradually rather than abruptly. Over time, those changes could become indistinguishable from natural evolution, yet still reflect a guiding influence at some point in the past. From our perspective, we would see a biosphere shaped by contingency, species distributions that make sense ecologically, but perhaps not historically, evolutionary paths that appear oddly efficient or convergent. Again, not proof, but possibility. There is also the matter of absence. Absence is harder to interpret than presence, but it can be just as telling. A lack of something expected can indicate prior depletion. Certain easily accessible resources, if heavily used in the distant past, might simply no longer be present in forms we would notice. We already see this with fossil fuels. They exist because vast amounts of ancient life were buried under specific conditions. If those deposits had been tapped earlier, they wouldn't regenerate on useful timescales. A later civilization would simply conclude that such resources never existed in abundance. Absence would look natural. This applies to metals as well. Certain rare earth elements are crucial for modern technology. If a prior civilization relied on similar materials and extracted them extensively, the remaining concentrations might be lower or more diffuse, not enough to raise alarms, but enough to subtly constrain what comes next. These kinds of traces wouldn't look like ruins because they wouldn't present as discrete objects. They would present as constraints, limits, slightly different starting conditions, the kind of thing you only notice when comparing one planet to another or one model to another. That comparison is important. We have only one Earth to study. We can't easily tell what is typical and what is unusual without a broader sample. When astronomers look at exoplanets, they're beginning to see a range of planetary environments. Some are wildly different, some are surprisingly Earth-like. Over time, patterns may emerge that help us understand what Earth's history implies. If, for example, Earth's atmospheric evolution turns out to be unusual compared to similar planets, that would raise questions, not immediate conclusions, but curiosity. Why did this planet maintain habitability for so long? Why did it avoid certain runaway scenarios? Why did it stabilize where others did not? There are natural explanations for all of these questions, but the hand-me-down idea lives in the overlap between explanation and uncertainty. It doesn't replace natural causes, it asks whether natural causes could have been nudged. Another category of trace is temporal mismatch. When something seems out of sync with its surroundings. For instance, when a geological feature appears earlier or later than expected, or when a transition happens faster than models predict. These mismatches already exist in Earth science. They usually resolve with better data or revised theories, but their existence reminds us that our understanding is incomplete. A prior civilization wouldn't need to cause dramatic mismatches to leave a trace. Even small deviations could ripple forward, especially in complex systems where feedback amplifies initial conditions. Think about climate. Small changes in atmospheric composition can have outsized effects over time. Feedback loops involving ice, vegetation, and oceans can lock in trajectories that persist for millions of years. If a civilization altered atmospheric chemistry slightly and then vanished, the planet could carry that change forward long after the cause disappeared. To later observers, that altered climate would simply be the baseline. The trace would not look like intervention. It would look like nature. This is what makes the idea both compelling and difficult. The more subtle the trace, the harder it is to distinguish from background variation. And the harder it is, the less confident any claim can be. That's why this idea doesn't fit neatly into discovery narratives. There may never be a moment where someone points to a rock layer and says, "Here it is." Instead, the idea persists as a framework, a way of thinking about Earth that remains open to revision. There's also an important caution here. Humans have a long history of seeing intention where there is none. Pattern recognition can become overreach. Every unexplained feature does not imply intelligence. Most things have natural explanations that simply haven't been fully worked out yet. The value of this idea is not in asserting hidden builders, it's in reminding us how easily traces disappear and how cautious we must be when interpreting absence. If a civilization existed before us, its traces would be quiet, not because it was careful, but because time is thorough. Time does not preserve meaning. It preserves what happens to survive regardless of origin. That realization also reframes how we think about our own traces. What will remain of us, not in centuries, but in tens of millions of years, probably not cities, probably not languages, maybe not even species. What might persist are changes in sediment composition, a spike in certain compounds, a brief anomaly in the geological record. Even then, those traces will blur. Future life, if it exists, may not recognize them as artificial. They will see layers, ratios, transitions. They may attribute them to volcanism, climate shifts, or evolutionary events. In that sense, our own civilization is already practicing leaving without ruins, not because we intend to, but because permanence is not an option on this time's scale. There is something oddly calming about that. It removes the pressure to be remembered forever. It places value on what happens now, not on how it's recorded. When thinking about traces that wouldn't look like ruins, it helps to abandon the idea of evidence as something obvious. Instead, think of evidence as something statistical, probabilistic, a slight tilt in the data. The planet, after all, is not a scrapbook, it's a dynamic system. Anything introduced into it becomes part of its ongoing behavior. Over time, cause and effect blur, origins dissolve. If Earth was shaped before, we are living inside the result, not walking among leftovers. That's why the idea doesn't feel like archaeology. It feels like ecology extended across time. And that naturally raises another question. If traces are this subtle, how would we even begin to notice them? What would prompt us to look differently at familiar things? What kinds of gaps or inconsistencies would draw attention not to ruins, but to the possibility that something once acted here and then faded completely? Time is the most effective eraser we know, not because it destroys everything quickly, but because it works patiently and without preference. It doesn't target what matters. It doesn't preserve what is meaningful. It simply keeps going, allowing processes to repeat until distinction fades. When thinking about the possibility of forgotten builders, time isn't just a backdrop, it's the central obstacle. It's the reason the idea feels slippery, difficult to confirm, and impossible to resolve cleanly. The problem begins with how humans naturally think about history. We imagine it as a chain. One event leading to another, records passed forward, causes remembered. That works reasonably well over short spans, a few generations, a few centuries, even a few thousand years if conditions are right. But beyond that, the chain breaks. Continuity becomes fragile. Memory turns into inference. Earth does not keep a diary. It keeps layers. Those layers don't preserve intent. They preserve outcomes, and even those selectively. Sediments accumulate unevenly. Rocks are recycled. Entire chapters are erased when tectonic plates slide beneath one another. From a geological perspective, forgetting is not an accident. It's the default state. This is where the idea of forgotten builders runs into its greatest difficulty. Not disbelief, but resolution. If something happened long enough ago, there may be no way to prove it. Either way, evidence doesn't just become scarce, it becomes ambiguous, and ambiguity is uncomfortable, especially in a scientific culture that values clarity. To understand why time is such a problem here, it helps to step back and consider how much of Earth's own history we already don't have. The oldest rocks on the surface are a little over 4 billion years old, but they're rare. Most of Earth's early crust has been destroyed or transformed. The first half-billion years of the planet's existence is largely inferred, not observed. We know it happened. We don't know exactly how it looked. Life itself leaves a surprisingly uneven record. For billions of years, life was microscopic. Soft-bodied organisms dominate Earth's history, and they fossilize poorly. Entire branches of the tree of life are known only indirectly. We infer their existence from chemical signatures, not physical remains. Now imagine trying to detect a civilization within that same fog. A civilization would not occupy the planet uniformly. It would exist in specific environments for specific durations, using materials that may not preserve well. Even at its height, it would represent a thin layer in deep time, a brief pulse. The further back you go, the thinner that pulse becomes relative to everything else. Eventually, it blends into noise. This is why time is not just a challenge for this idea. It's what defines it. The question isn't whether we have missed obvious signs, it's whether obvious signs could exist at all after long enough. There's also a mismatch between human time and planetary time that complicates intuition. We think in lifetimes, careers, historical eras. Earth thinks in cycles of tens of millions of years. Climate regimes last longer than civilizations. Oceans open and close over spans that dwarf recorded history. When something operates on planetary timescales, short-lived phenomena barely register. A civilization lasting 1,000,000 years feels vast to us. To Earth, it's a flicker. This mismatch leads to false expectations. We expect permanence where there is none. We expect clarity where there is only residue. Another aspect of the time problem is that change does not stop when a civilization disappears. It continues to act on whatever remains. Even if a prior civilization left behind something durable, it would not remain frozen in place. It would be weathered, buried, altered, and eventually repurposed by natural processes. Consider how minerals form. They often incorporate elements from older rocks. Matter is reused constantly. There is no final state. Even the atoms in your body have passed through countless previous forms. If a civilization used materials extensively, those materials would not vanish. They would disperse, re-enter cycles, become anonymous. From that perspective, the idea of forgotten builders stops being mysterious. It becomes expected. Builders are forgotten not because no one cared to remember them, but because the system they operated within does not preserve identity. Time also complicates causality. When something happens far enough in the past, its effects can be separated from its cause by layers of intervening processes. Feedback loops amplify some changes and dampen others. Secondary effects can overshadow primary ones. For example, a small alteration to atmospheric composition could trigger climate feedbacks that dominate the signal. Later observers would see the feedback, not the trigger. The original cause would be invisible, absorbed into the system's behavior. This is not hypothetical. Earth's history is full of such cascades. The rise of oxygen driven by early life transformed the planet completely. The organisms responsible were not trying to engineer a new atmosphere. They were simply metabolizing. Their impact, however, was enormous and long-lasting. If unintentional life can reshape a planet so thoroughly, intentional action doesn't need to be dramatic to matter. It only needs to align with existing feedbacks. But time ensures that alignment is what remains, not the action itself. There's also a deeper issue. Our tools for understanding the past are calibrated to answer specific questions. Geology looks for processes that repeat. Biology looks for evolutionary patterns. Chemistry looks for reactions governed by physical laws. None of these fields are designed to detect intention directly. They infer mechanisms, not motives. Even in human archaeology, intention is inferred cautiously, and that's with artifacts only thousands of years old. Push that back millions of years and intention becomes nearly impossible to establish. This doesn't mean the idea of forgotten builders is unscientific. It means it lives in a space where science intersects with uncertainty, where hypothesis cannot be cleanly falsified because the evidence, if it ever existed, may no longer be distinguishable from background processes. That discomfort is part of why the idea tends to linger rather than resolve. It resists closure. Time also affects how we interpret continuity. We often assume that if a civilization existed, it would leave a clear evolutionary lineage or cultural continuity. But continuity requires transmission. It requires overlap. If enough time passes between civilizations, there is no overlap, no handoff, no inheritance of knowledge. Earth has experienced mass extinctions that erase dominant life forms entirely. Recovery took millions of years. New ecosystems emerged that bore little resemblance to what came before. If intelligence arose before such an event, it could be completely severed from what followed. In that case, later intelligence would not be descendants. They would be successors in a looser sense, sharing a planet, but not a lineage. That distinction matters. It means we wouldn't expect to find clues encoded in DNA or myths passed down unconsciously. The gap would be too large. Time also reshapes landscapes beyond. Recognition. River systems shift. Coastlines move. Entire continents rearrange. A location that was once central might now be buried deep beneath sediment or subducted into the mantle. Any attempt to map ancient activity onto modern geography risks projecting present-day significance backward. The places that matter now are not the places that mattered then. This makes targeted searches difficult. There is no obvious place to look. And yet, the idea of forgotten builders persists because time doesn't eliminate all information. It compresses it. It distorts it. But it also preserves certain things remarkably well under the right conditions. Chemical signatures can last. Isotopic anomalies can persist. Some minerals trap information for billions of years. Zircon crystals, for example, preserve data about early Earth conditions long after surrounding rocks have been recycled. If something unusual happened, some trace might still exist, but not as a story, as a number, a ratio, a distribution. The challenge is that such traces rarely point to a single explanation. They widen the space of possibilities rather than narrowing it. That's the core of the time problem. The deeper you go, the more explanations converge. Natural and artificial causes begin to overlap in their signatures. Distinguishing them becomes less about detection and more about inference. This is why forgotten builders, if they existed, are likely to remain forgotten. Not because the idea is wrong, because the system does not retain the resolution needed to answer the question definitively. There's something important to notice here. The inability to know is not a failure of inquiry, it's a property of the system being studied. Earth is not obligated to preserve its past in a way that satisfies later curiosity. In that sense, the problem of time is not a barrier to understanding. It's part of understanding. It also invites humility. We're used to thinking of ourselves as observers who can, given enough effort, reconstruct any past. Time reminds us that some things are lost not because we didn't look hard enough, but because loss is built in. This humility extends to how we think about our own future visibility. If intelligence appears again on Earth long after humans are gone, will they know we were here? Maybe. But more likely, they will know us only indirectly, if at all. Through faint chemical signals, through a brief anomaly in the record, through patterns that suggest something happened without explaining what. From their perspective, we might look like forgotten builders. That reversal is not meant to unsettle. It's meant to normalize the idea. We are not special in being hard to remember. Everything is time equalizes. It reduces everything to influence rather than identity. When people imagine advanced technology, they usually picture separation. Machines over here, nature over there, clean lines, hard edges, materials that resist weather and decay. That picture comes from our current stage of development where technology is still something we impose onto the environment rather than something that fully participates in it. But that picture may not be stable over long periods of time. In fact, it may represent a very early and very temporary phase in how intelligence interacts with a planet. If a civilization existed on Earth long before us and lasted long enough to learn the limits of extraction and disruption, its technology might have followed a very different trajectory. Not toward greater visibility, but toward disappearance. Not because it vanished, but because it merged. Blending into nature does not mean abandoning technology. It means changing the way technology functions and how it leaves traces. The more a system aligns itself with existing planetary processes, the less it stands out over time. From a distance, it stops looking like intervention and starts looking like environment. We already see the beginning of this shift in our own world. Early human technology was simple and obvious. Stone tools, fire pits. Later came metalwork, cities, roads, and large-scale infrastructure. These left clear marks. But as technology advances, there is increasing pressure to reduce waste, reduce energy loss, and reduce long-term damage. Efficiency pushes systems to become quieter. Biology offers a clear example of this principle. The most successful organisms are not the loudest or the strongest. They are the ones that integrate smoothly into their ecosystems. They recycle energy effectively. They use materials that break down and re-enter cycles. They persist by not overloading their surroundings. A mature technological civilization might follow the same logic. Its most advanced tools would not be monuments. They would be processes, feedback systems, self-regulating networks that operate in concert with planetary cycles rather than against them. If that were the case, the technological footprint of such a civilization would not resemble ruins. It would resemble altered baselines, slightly different equilibria. A planet that behaves a bit differently than it otherwise would without any obvious cause visible at the surface. Consider energy use. Early industrial societies rely on concentrated energy sources, burning fuels, splitting atoms. These methods produce waste that is difficult to hide and slow to reintegrate. But over time, there is incentive to shift toward diffused renewable energy flows, sunlight, chemical gradients, thermal differences, systems that already exist and can be tapped without overwhelming them. A civilization that mastered such energy use would not need massive infrastructure. It would not need mines or smokestacks. Its energy systems might resemble biological metabolism more than factories, spread out, redundant, quiet. From a geological perspective, that kind of technology would leave very little behind. There would be no sudden spikes in pollutants, no thick layers of industrial residue, just long-term participation in cycles that already operate. The same applies to materials. Human technology has long favored durability. We build things to last decades, sometimes centuries. But durability is a double-edged sword. Materials that resist decay become waste when they are no longer needed. Over long periods, they accumulate and disrupt systems. A more advanced approach would favor materials that perform their function and then return to simpler states. Materials that biodegrade, materials that dissolve harmlessly, materials that change form rather than persist. Again, this is not speculation without precedent. Living organisms already do this. Bones dissolve, shells break down, organic structures return nutrients to ecosystems. Even hard materials like calcium carbonate cycle through environments. If a civilization learned to build using materials that follow similar rules, its technology would vanish when no longer maintained, not violently, but quietly. It would leave no piles of debris, no obvious artifacts for later observers to find. Information storage offers another example. Human societies store information externally: books, databases, servers. These require maintenance. Without it, they decay rapidly. Over millions of years, they would not survive. But information does not need to be stored externally to persist. Biology stores information in living systems. Genetic codes persist as long as life continues. Behavioral patterns pass through learning. Ecosystem structures encode history. A civilization that embedded its knowledge into living systems, rather than static records, would leave no libraries to discover. Its information would persist only as long as the systems carrying it persisted. When those systems changed or vanished, the information would vanish with them. From the outside, that would look like nothing was ever there. Technology that blends into nature would also avoid centralized control. Centralization creates single points of failure. It concentrates impact. Distributed systems are more resilient. They fail locally rather than globally. They are harder to disrupt and harder to detect as unified systems. Nature favors distributed organization. No single cell controls an ecosystem. No single organism runs a forest. Intelligence in such a system could be collective rather than centralized. Decision-making spread across networks rather than housed in institutions. If intelligence took that form, later observers might not recognize it as civilization at all. They would see complex ecosystems behaving adaptively. They would see stability and resilience. They would attribute it to natural selection and self-organization, and they would not necessarily be wrong. This raises an uncomfortable question. How do we define technology? Is it a tool held in the hand, or is it any system designed to achieve outcomes reliably? By that definition, many biological processes already qualify as technology, even though they evolved rather than being consciously engineered. A prior civilization might not draw the same boundaries we do. It might not separate technology from environment. It might see the planet itself as the platform, not something to be reshaped, but something to be guided gently. That guidance would not look like construction. It would look like tuning, adjusting flows, encouraging certain feedbacks, discouraging others, working with timescales far longer than individual lifetimes. Such an approach would leave almost no archaeological footprint. The most visible phase would be early experimentation. Once the system stabilized, intervention would become minimal. Time would do the rest. This idea also explains why technology that blends into nature would be especially hard to recognize after the civilization that created it disappeared. Without maintenance, systems would gradually revert to baseline behavior. The guiding influence would fade. The planet would continue operating under its own dynamics. Later observers would see a planet that appears natural because at that point it is natural. Any prior influence would be fully absorbed. This does not require advanced foresight or benevolence. It follows from optimization. Systems that survive long-term are those that minimize disruption to their host environment. Anything else eventually collapses. From this perspective, the absence of ruins becomes less mysterious. Ruins are signs of immaturity. They belong to civilizations that built in ways that resisted nature rather than integrating with it. If a civilization matured past that stage, it would stop producing ruins entirely. There is also an ethical dimension to this idea, though it doesn't need to be emphasized. A civilization that sees itself as temporary would have little incentive to leave permanent marks. Permanence would be viewed as risk rather than achievement. Instead of carving signatures into stone, it might aim to leave the planet capable of continuing without it, not as a gift to the future, but as a requirement for its own survival. That perspective aligns closely with what ecology teaches. Systems that overshoot collapse, systems that balance persist. From a later vantage point, that persistence would look like nature functioning well. No scars, no warnings, no evidence of effort. This is perhaps the most unsettling part of the idea. The more advanced and careful a civilization is, the harder it would be to detect. The civilizations that leave obvious ruins are the ones that fail to integrate. In that sense, invisibility is not a sign of absence. It may be a sign of success. There is precedent for this logic even in human history. Some societies leave behind massive monuments, others leave behind almost nothing. That difference often reflects values rather than capability. Nomadic cultures, for example, left few permanent structures, yet they were highly sophisticated in terms of knowledge, social organization, and environmental adaptation. Their traces are subtle and often overlooked. Scale that difference up to planetary timescales, and it becomes extreme. Technology that blends into nature would also challenge our detection methods. We look for anomalies, sharp boundaries, clear discontinuities, but blended systems create gradients, not edges. They produce smooth transitions that are easy to interpret as natural variation. This makes the idea resistant to both proof and disproof. It sits comfortably within uncertainty, and that is why it continues to hold attention without demanding belief. There is another layer to this idea that deserves consideration. If technology can blend into nature, then nature itself may already contain layers of design that are no longer distinguishable from an emergence. This does not imply intentional creation of life or planets. It implies that once a system reaches sufficient complexity, the difference between guided and unguided outcomes becomes difficult to detect after enough time passes. We already struggle with this distinction in artificial intelligence. At what point does a system trained by humans behave independently? At what point does authorship blur? Over time, the origin matters less than the behavior. Apply that to a planet, and the distinction between engineered and evolved states becomes increasingly academic. This is not an argument that Earth was engineered. It is an argument that engineering, if it occurred long enough ago, would no longer be visible as such. That realization shifts the question again. Instead of asking what a prior civilization built, the question becomes how it might have interacted. What kinds of interventions persist longest without maintenance? The answer consistently points toward integration rather than construction. If you step back far enough from the details, Earth's history does not read like a continuous story. It reads like a manuscript with missing pages. Some sections are rich with detail, footnotes layered on footnotes, data piled high. Other stretches are thin, speculative, reconstructed from fragments and inference. These gaps are not unusual, they're expected. A planet that constantly reshapes itself cannot preserve everything evenly. But once you start thinking about Earth as a place that may have hosted more than one phase of intelligence, those gaps take on a different weight. Not as evidence, not as accusation, but as space where certainty simply cannot reach. The story of the planet as we tell it is assembled from what survives. Rocks that escaped recycling, fossils that formed under rare conditions, chemical signatures that endured long enough to be measured. What's missing is not highlighted, it's implied. And those implications are vast. Entire eras are known only in outline. We know they happened. We know roughly what conditions were like, but the fine detail, the day-to-day reality, the complexity of systems operating then is gone. Take the earliest chapters of Earth's history. The Hadean and early Archean eons account for a significant portion of the planet's lifetime. Yet, they are among the least understood. Surface rocks from that time are almost entirely absent. What we know comes from minerals trapped inside younger formations, tiny time capsules preserved by chance. From these, scientists infer temperatures, water presence, and broad conditions, but inference has limits. It cannot recover everything that might have occurred. Even later periods closer to our own time are unevenly recorded. The fossil record, despite its richness, is famously incomplete. Soft-bodied organisms dominate Earth's history, yet they fossilize poorly. Ecosystems that thrived for millions of years may leave behind almost no trace. Evolutionary lineages appear suddenly in the record, not because they emerged overnight, but because preservation conditions finally aligned. These discontinuities are usually explained and often correctly by preservation bias. Certain environments favor fossilization. Certain periods produced more sedimentary rock. Certain regions have been studied more extensively. None of this is controversial, but it does mean that absence cannot be treated as strong evidence of non-existence. Now, extend that logic beyond biology. Imagine trying to reconstruct the presence of a technological civilization under those same constraints. A civilization would occupy specific environments. It would operate for a limited duration. It would depend on materials that may or may not preserve. It would exist as a thin layer in a record already full of holes. The story would not simply be missing details. It might be missing entire categories of activity. This is where strange gaps become conceptually important, not because they hide answers, but because they define the limits of what can be known. Some gaps are obvious. Mass extinctions mark sharp boundaries. Sudden climate shifts stand out in ice cores and sediment layers, but other gaps are quieter. They appear as periods of relative stability where little seems to change, or as transitions that occur faster than expected. In Earth science, these gaps are not ignored. They are studied carefully. Researchers propose mechanisms, volcanism, orbital changes, tectonic rearrangements, biological innovation. Most of the time these explanations are sufficient. Sometimes they remain provisional for decades. Occasionally they are revised entirely. What matters here is not whether current explanations are right or wrong. It's that the record itself does not enforce completeness. It allows for interpretation, revision, and uncertainty. Consider one example. There are intervals in Earth's history where atmospheric composition appears to have shifted relatively rapidly. Oxygen levels rose, fell, or stabilized in ways that are still being debated. These changes are generally attributed to biological activity and geochemical feedbacks, and again, those explanations are strong, but they also highlight how sensitive planetary systems are to relatively small inputs. A slight change in one variable can cascade into large-scale transformation. Feedback loops amplify effects. Initial causes become obscured by subsequent dynamics. If a civilization existed and interacted with Earth's systems, even modestly, its influence could be amplified in this way. Not enough to create an obvious signature, but enough to nudge trajectories. Over time, those nudges would be indistinguishable from natural variability. Later observers would see the outcome, not the cause. This is one of the most difficult aspects of the idea to grapple with. The deeper you look into the past, the less linear causation becomes. Events do not leave clean fingerprints. They leave tangled consequences. Another kind of gap appears in the form of mismatched timescales. Some geological and biological changes happen faster than models predict. Others take longer. These discrepancies are not necessarily signs of missing factors, but they do remind us that models are simplifications. They are tools, not mirrors of reality. Earth systems are complex beyond full description. They involve countless interactions across scales. Small perturbations can have long-lasting effects, while large disturbances can be absorbed and forgotten. When thinking about strange gaps, it's important to resist the urge to fill them with speculation. The goal is not to insert a hidden civilization wherever knowledge is incomplete. That would be careless. The goal is to recognize that incompleteness exists and that it places limits on what we can confidently rule out. There is a subtle but important difference between we have no evidence and evidence could not survive. In many parts of Earth's story, the latter applies. Another gap appears when we consider how unevenly the planet has been explored. Large portions of Earth's crust are inaccessible. Deep ocean floors remain poorly mapped. Subsurface environments are largely unknown. Even on land, vast regions have been studied only superficially. Most of what we know about Earth's deep past comes from a relatively small number of sites. These sites are treated as representative, but they are also special. They survived, they were exposed, they were accessible. They may not tell the whole story. This does not mean there are hidden cities waiting to be found. It means that the sample is incomplete. Any conclusions drawn from it must acknowledge that limitation. Strange gaps also exist in how we define significance. We focus on events that changed life dramatically: mass extinctions, evolutionary radiations, climate catastrophes. But a civilization could exist without triggering such markers. It could operate below the threshold of global disruption, especially if it learned to avoid destabilizing feedbacks. In that case, its presence would not coincide with obvious turning points. It would be layered quietly within a period we already consider stable. From our perspective, that period would look unremarkable. From within it, the civilization would experience history, progress, and decline. From outside it, millions of years later, it would barely register. There's also a gap created by anthropocentrism. We assume intelligence manifests in certain ways because that's how it manifested in us. We look for energy consumption patterns similar to ours. We look for centralized structures. We look for waste products we recognize. But those expectations are shaped by a single data point. One species, one planet, one brief moment. They are not laws. A civilization that developed under different constraints might prioritize different solutions. Its footprint could be narrower. Its technologies could be more ephemeral. Its organization could be less visible. In that case, the gap is not in the record. It's in our expectations. Another strange gap lies in the transition from pre-technological to technological life. For humans, this transition is recent and well documented. For other potential intelligences, we have no data. We don't know how often intelligence arises. We don't know how often it becomes technological. We don't know how long those phases last relative to planetary lifetimes. Earth's habitability window spans billions of years. Human technological civilization has existed for a few centuries. Even if intelligence arose only once every billion years, that would still allow for more than one occurrence on Earth. The gap here is statistical. We simply don't have enough examples to draw strong conclusions. There is also the issue of survivorship bias. We are here, so we observe a planet that supports us. We are the kind of civilization that did not destroy itself immediately. That skews perception. We may be looking at a filtered outcome rather than a typical one. If previous civilizations tended to end quietly or integrate into their environment, they would be less likely to leave detectable traces. If they tended to end catastrophically, they might leave clearer signals, but only briefly before time erased them. Either way, time works against clarity. One of the most unsettling gaps is conceptual rather than empirical. It's the gap between what we know we don't know and what we don't realize we don't know. Unknown unknowns. Entire categories of processes that have not yet been imagined. Science advances by expanding its vocabulary. New tools reveal phenomena that were previously invisible. Plate tectonics was once unthinkable. Microbial ecosystems were unknown. Dark matter remains mysterious. Each discovery reshapes what questions are even possible. It is entirely plausible that aspects of Earth's past fall into this category. Processes that leave subtle distributed traces that current frameworks cannot detect or interpret. That possibility does not validate any specific claim. It validates caution. Strange gaps in the story of the planet are not invitations to invent. They are reminders of humility. They tell us that Earth's history is deeper and more complex than any single narrative can capture. At the same time, they encourage curiosity. Not the kind that rushes to conclusions, but the kind that lingers with questions without demanding closure. If a civilization existed before us, its story would likely be buried in these gaps. Not hidden intentionally, simply lost to processes that do not preserve detail. The builders would be forgotten not because no one looked for them, but because the medium they built upon does not remember well. And that realization loops back to something quieter. The planet does not privilege intelligence in its record. It treats it like everything else, as activity, as process. There's something that happens and then is folded into what comes next. From that perspective, the gaps are not suspicious, they are normal. Yet once you notice them, they are hard to ignore. They sit between what we can reconstruct and what we cannot. They widen as we look further back. They remind us that the story we tell is not the story that happened. It's a version assembled from fragments. That does not make it false, it makes it incomplete. As this thought continues to unfold, it naturally raises another question. If the gaps are real and unavoidable, how should that change the way we interpret silence? Not just the silence of missing artifacts, but the silence of the planet itself, the absence of signals, the lack of obvious predecessors. Is silence evidence of absence, or simply the expected outcome of deep time doing what it always does? Imagine arriving somewhere long after the activity has stopped. Not ruins still warm, not doors swinging in the wind, but a place where whatever once happened, there has had time to fully settle. Dust has settled, systems have equalized. Any sign of urgency is gone. That is the feeling behind the idea. That we may have arrived after the lights went out. Not late to the event, not even late to the cleanup, but late to the memory that anything happened at all. This idea shifts the tone of the question. It is no longer about discovery in the dramatic sense. It is about timing, about sequence, about what it means to show up on a planet whose most intense phase of prior activity, if it existed, ended so long ago that even its absence feels natural. When the lights go out in a human city, the change is obvious at first. Noise fades, movement stops, infrastructure cools. Over time, vegetation creeps in, animals return. Eventually, the city becomes something else entirely. Given enough time, even the outline disappears. What remains is land shaped by history, but no longer signaling it. Now expand that image beyond cities, apply it to a planet. If Earth once hosted a civilization that reached a point of high complexity and then faded away, the end would not have looked like a sudden blackout. From the planet's perspective, there would be no single moment where everything stopped. Energy use would decline gradually. Networks would fragment. Maintenance would lapse. Systems would decouple. By the time the lights fully went out, there may have been no one left to notice. From our position now, that ending would not look like an ending at all. It would look like a long period of quiet normality. Forests growing, oceans cycling, life continuing, the planet doing what it does best when pressure is removed. This is one of the most important reframings in the entire idea. We often assume that the end of a civilization must be marked by violence or catastrophe. But in reality, the most complete erasers are often the least dramatic. They are the ones that leave no sharp boundary. Earth's geological record is full of sharp boundaries. Asteroid impacts, massive volcanic events, sudden extinctions. These stand out because they disrupt everything at once. But if a civilization declined without triggering such events, it would not leave a boundary layer. It would fade into continuity. Later observers would not see a line and say, "Here is where it ended." They would see an uninterrupted flow of natural processes. Arriving after the lights went out also means arriving after repair. Nature is remarkably good at rebalancing systems once intense activity stops. Erosion smooths scars. Biological communities reoccupy niches. Chemical cycles re-establish equilibrium. Given enough time, the planet forgets stress. This forgetting is not selective. It does not preserve what was important to those who lived there. It preserves what fits. If a civilization altered Earth's systems in ways that were not catastrophic, those alterations might persist for a while, then gradually be absorbed. Climate shifts would settle into new baselines. Species introduced or removed would find new equilibria. Nutrient cycles would adjust. Eventually, the planet would look stable again. Not because nothing happened, but because everything that could happen has already been integrated. From the outside, that stability would appear natural. From the inside, millions of years earlier, it might have been hard-won. The phrase "after the lights went out" also suggests something else. It suggests that there was a peak, a time of maximum activity, maximum energy flow, maximum information exchange. After that peak, decline was not necessarily failure. It may have been unavoidable. Every system that grows faces limits, energy availability, environmental tolerance, complexity costs. At some point, growth slows, then it stops. What happens next depends on how the system responds. Some systems collapse under their own weight. Others simplify and persist. Others transform into something less visible but more stable. If a civilization reached a level where further growth threatened its own survival or the planet's stability, it might have chosen contraction. Less energy use, less expansion, less visibility. Over time, that contraction could erase the markers we associate with civilization. By the time the last lights went out, the planet may have already been well on its way back to equilibrium. This also changes how we think about inheritance. If we arrived after the lights went out, we did not inherit a world full of active systems built for us. We inherited a world that had already finished digesting a prior phase. Any compatibility we experience is incidental. Any resources we use are leftovers, not in a material sense, but in a systemic one. Earth's current state would not be a gift, it would be a result. That distinction matters. It removes intention from the equation. No one prepared the world for us. No one left us tools or warnings. We arrived because conditions allowed us to, not because we were expected. From that perspective, silence becomes less mysterious. There is no reason for the planet to speak about what came before. The planet does not narrate. It simply continues. Another aspect of arriving after the lights went out is that we may be mistaking quiet for emptiness. A planet that looks inactive at one scale may still be active at another. Low energy systems, slow processes, distributed interactions. If a civilization transitioned into forms that operate on geological or ecological timescales rather than technological ones, its activity would be invisible to us. We are tuned to fast signals, rapid change, high contrast. Anything slower than our attention span blends into background. This is already true for many natural processes: soil formation, deep ocean circulation, mantle convection. These shape the planet profoundly, yet we barely notice them. An intelligence operating at those tempos would not register as on or off in the way we expect. The concept of lights going out may not apply cleanly. It may be more like a dimming that eventually becomes indistinguishable from ambient glow. That idea challenges another assumption. We often equate activity with noise, energy use with disruption, visibility with existence. But many stable systems are quiet precisely because they are efficient. From that perspective, the loudest phase of a civilization may be its least sustainable one. The phase most likely to leave obvious traces is also the phase least likely to last. If that is true, then the absence of noise in Earth's deep path does not argue against prior intelligence. It may argue that any such intelligence did not remain noisy for long. There is also a timing problem worth considering. Humans tend to assume that if a civilization existed before us, it must have been recent enough to leave recognizable traces. But Earth's habitability window is vast, billions of years. Our entire species occupies a tiny fraction of that span. Even if intelligence arises only rarely, the window allows for more than one occurrence. And if those occurrences are separated by hundreds of millions of years, overlap is impossible. Memory cannot bridge that gap. Arriving after the lights went out means arriving after forgetting was complete. This also reframes how we think about discovery. We often imagine that if something important happened, it would be discoverable given enough effort. That belief is comforting. It suggests that knowledge is limited only by curiosity and tools. Deep time contradicts that belief. Some things are not discoverable because the information needed to reconstruct them no longer exists in a usable form. Not hidden, destroyed, dissolved into background. This is not pessimism, it is realism. Earth has already erased most of its own history. The fact that we know as much as we do is remarkable. Expecting it to preserve the details of every complex process is unrealistic. There is a quiet humility in accepting that we may have arrived too late to know everything, that some questions will remain open not because they are poorly formed, but because the answers are no longer accessible. This does not mean inquiry stops. It means inquiry changes. Instead of seeking proof, we seek context. Instead of certainty, we seek plausibility. Arriving after the lights went out also places us in an interesting position ethically. If others came before and are gone, we're not the first to face the problem of long-term survival. We are part of a sequence of attempts. That does not imply inevitability. It implies learning not from direct instruction but from inference. Observing what persists and what does not. The planet itself becomes the lesson. What has lasted here? Stable climates within limits, distributed ecosystems, cycles that recycle waste, systems that do not overshoot dramatically. What has not lasted? Extreme imbalances, unchecked feedbacks, rapid concentrated exploitation. Whether or not a prior civilization existed, these patterns are real. They are written into the planet's behavior. Arriving after the lights went out means inheriting those patterns without knowing their origin. We may be mistaking hard-won stability for baseline normality. That mistake matters because it affects how we behave. We assume the world is naturally generous and resilient without limit. We are more likely to push it beyond those limits. If we assume stability is fragile and contingent, we are more cautious. The idea of arriving late subtly encourages the second mindset, not because it frightens, but because it contextualizes. It suggests that habitability is not guaranteed. It is maintained whether intentionally or not by alignment with planetary processes. There is also a personal dimension to this idea. Humans like to imagine themselves at the center of stories. Arriving after the lights went out removes that comfort. It places us not at the beginning but somewhere in the middle of a very long sequence that can feel diminishing. It can also feel freeing. We are not responsible for the entire story, only for our part. The silence of the past does not accuse us, it does not warn us explicitly. It simply exists. And silence in this context is not emptiness. It is what remains after activity has been fully absorbed. If we arrived after the lights went out, what does that say about the silence we currently hear when we look outward? Long before any answers appear, silence makes itself known. Not the quiet of a paused moment, but the kind that stretches without interruption. The kind that remains no matter how carefully you listen. When people talk about silence in the context of civilizations, they often mean absence. No signals, no messages, no unmistakable signs of activity. Silence can mean many things. And one of the most uncomfortable possibilities is that it does not mean nothing ever happened, but whatever happened is already over. This is the idea behind the silence that might mean too late. Not too late for rescue or contact, but too late for overlap, too late for coexistence, too late for one civilization to witness another while both are active at the same time. On Earth, we're accustomed to overlap. Human history is built on it. Cultures rise while others still exist. Knowledge passes between generations. Even when civilizations collapse, their neighbors notice. There is continuity even through disruption. That experience shapes how we imagine intelligence elsewhere and how we imagine intelligence in the past. We expect simultaneity. We expect witnesses. Deep time does not offer that luxury. If civilizations are rare and short-lived compared to planetary timescales, silence becomes the default condition rather than the exception. Most of those time, no one is around to hear anyone else. The absence of noise is not evidence of emptiness. It is evidence of timing. This reframing is essential because without it, silence feels accusatory. It feels like a mystery demanding explanation. With it, silence becomes expected. On Earth, the silence of the past is profound. For most of the planet's history, there were no animals, no plants, no complex ecosystems, just microbes quietly shaping chemistry. If an intelligent civilization existed, during one of those long stretches, it would be silent to us now, not because it was insignificant, but because we were not there to hear it. That same logic scales outward. When astronomers search the sky for signs of intelligence, they're often guided by a question that sounds simple, but hides an assumption. Where is everyone? The assumption is that if intelligence arises elsewhere, it should be detectable now. But that assumes overlap in time. It assumes that civilizations emerge, persist, and signal within a shared window. If instead intelligence is episodic, scattered across time rather than space, then silence is not surprising. It is the natural result of non-overlapping lifetimes. This applies just as much to Earth's past as it does to the wider universe. If we arrived after the lights went out here, then Earth's silence is not a failure of detection. It is a consequence of arrival time. The phrase "too late" carries emotional weight, but it does not imply tragedy. It implies sequence. You can arrive too late to hear music that already ended without that music having failed. You simply missed it. Civilizations, especially technological ones, may have lifespans measured in thousands or millions of years. That sounds long to us. Compared to geological time, it is brief. Compared to cosmic time, it is almost negligible. Earth has been capable of supporting life for billions of years. If intelligence arose once every billion years and lasted 1,000,000 years each, the odds of overlap would be small. Two intelligent civilizations could exist on the same planet and never know of each other. In that scenario, silence is not suspicious. It is inevitable. There's also a psychological tendency to interpret silence as a void rather than a residue. We are wired to notice presence, not absence. When something is not there, we assume it never was. But in systems that erase history, absence is often the final state of prior presence. Consider erosion A. Mountain does not disappear suddenly. It is worn down grain by grain until it becomes part of the landscape. At the end, there is no mountain-shaped hole, there is just land. Silence works the same way. Activity does not leave a silent-shaped outline when it ends. It leaves continuity. If a civilization ceased long ago, Earth would not feel empty afterward. It would feel stable, balanced, alive in different ways. That stability would be mistaken for baseline reality. The silence that might mean too late is therefore deceptive. It feels like a starting point when it may actually be an aftermath. This idea also applies to technological signals. Radio transmissions, for example, spread outward at the speed of light, weakening as they go. They are temporary. Even if a civilization broadcasts continuously for centuries, that signal occupies only a thin shell of time. If no one is listening while that shell passes, it is gone forever. Earth's own radio bubble is small on cosmic scales. It is already thinning. Eventually, it will fade into background noise. Future observers, if any exist, may not detect it at all. They may conclude that Earth was always silent. That conclusion would be wrong, but understandable. The same logic applies backward. If a civilization on Earth used technologies that produce detectable signals, those signals would not persist indefinitely. They would fade. They would scatter. They would be overwritten by noise. By the time we arrived, the silence would be complete. Another uncomfortable aspect of this idea is that silence can feel like judgment, as if the universe is withholding answers. But silence does not care. It does not respond to curiosity. It simply reflects conditions. We often imagine that if something important happened, the universe would leave a clue. That belief is deeply human. It assumes a kind of narrative fairness. But the universe does not operate on narrative principles. It operates on physics. Physics does not guarantee preservation. It guarantees change. The silence that might mean too late is therefore not ominous. It is ordinary. There is also an asymmetry in how we think about beginnings and endings. Beginnings feel meaningful, endings feel final. But from the planet's perspective, both are transitions. Life appears. Life disappears. Systems reorganize. Earth has experienced multiple mass extinctions, each one dramatically reshaped life. From the perspective of species that survived, the planet continued. From the perspective of species that vanished, the story ended. If an intelligent civilization existed and vanished, its silence would be indistinguishable from the silence left by extinct species. The difference would be significance to us, not to the planet. That realization can be unsettling, but it is also clarifying. It strips away the idea that intelligence is cosmically privileged. It treats it as another pattern that may appear and disappear under the same rules as everything else. This does not diminish intelligence. It contextualizes it. Silence also interacts with expectation. We expect evidence to look like us: cities, machines, signals. When those are absent, we conclude absence of intelligence. But intelligence that does not rely on persistent signaling or durable infrastructure would not leave the kind of silence we expect. It would leave a silence that feels natural. That kind of silence is especially hard to interpret because it does not feel like something is missing. It feels complete. A forest does not feel silent because it lacks a city. It feels whole because it functions on its own terms. If a city once existed there and then disappeared long ago, the forest would not carry that memory. Earth may be like that forest. The silence that might mean too late also affects how we think about urgency. If civilizations are brief, then overlap is rare. Communication across time becomes the greater challenge than communication across space. This reframes the idea of contact. Instead of asking how far away others are, the more relevant question becomes when they existed. Two civilizations could be separated by billions of years and share the same planet, the same star, the same location, and still never meet. That thought can feel lonely. It can also feel strangely peaceful. It removes competition. It removes hierarchy. It replaces them with sequence. We're not being ignored. We're simply early, late, or between. This perspective also changes how we interpret responsibility. If silence means too late, then the most important audience for our actions is not the distant past or the distant future. It is the present and the near future. Legacy becomes less about being remembered and more about what persists while we are here. That shift aligns with what Earth itself seems to value. Persistence through balance, adaptation through integration, survival through restraint. Whether or not a prior civilization existed, the silence of the planet teaches this lesson repeatedly. Loud phases end, quiet phases endure. The danger comes when silence is mistaken for permission, when a stable-looking world is assumed to be infinitely resilient, when the absence of warnings is taken as proof that none are needed. If Earth has absorbed previous disruptions and returned to equilibrium, that does not mean it can absorb unlimited disruption indefinitely. It means it recovers on timescales far longer than those relevant to civilizations. Silence does not promise safety. It only indicates that processes are ongoing. There is also a mirror here. One day, if humanity disappears, Earth will go silent again. Not instantly, but gradually. Our signals will fade. Our structures will decay. Our influence will be absorbed. Future life, if it arises, may never know we were here. Or it may know only indirectly through a brief anomaly in the record. From their perspective, our silence would not mean we never existed. It would mean they arrived too late. That symmetry is worth sitting with. It places us on both sides of the question, listener and subject, observer and potential ancestor. Silence, then, is not a wall. It is a horizon. Beyond it, things may have happened that are no longer accessible. That does not make inquiry pointless. It makes it careful. Rarely does this question begin with technology at all. It begins with behavior. If something lived here before us and left the planet behind in a state that feels complete, rather than damaged, then whatever it was did not relate to Earth the way humans currently do. That single observation narrows the field more than any speculation about tools or intelligence ever could. The kind of beings that leave worlds behind without obvious scars are not defined by what they build, but by how they interact, how they limit themselves, and how they understand time. To leave a world behind quietly requires restraint, not accidental restraint, but restraint sustained over long periods. That alone tells us something important. Any intelligence capable of altering a planet is also capable of overwhelming it. The difference between devastation and disappearance is not power but choice. Human history offers an early-stage example of this tension. Soon as we learned how to extract energy efficiently, we began changing our environment faster than we could fully understand the consequences. Forests disappeared, species vanished, atmospheres shifted. None of this required malicious intent. It followed naturally from capability, combined with short-term priorities. If a civilization existed before us and avoided, leaving a visible wound in the geological record, it likely passed through a phase like this and then corrected course. That correction would not be cosmetic. It would require a fundamental shift in how success was measured. The beings capable of leaving worlds behind would not define progress as expansion alone. They would not equate growth with improvement indefinitely. At some point, they would recognize that planetary systems have limits that cannot be negotiated with technology alone. This recognition changes everything. Once limits are internalized rather than resisted, the trajectory of a civilization bends away from accumulation and toward equilibrium. Energy use becomes deliberate rather than maximal. Materials are cycled rather than consumed. Systems are designed to fail softly rather than catastrophically. That kind of intelligence would not be loud. It would not be obvious. Its most advanced phase would likely look less impressive than its earlier, more disruptive one. From our perspective, this is counterintuitive. We associate advancement with complexity and scale. Bigger cities, faster networks, more output. But those traits are not necessarily aligned with longevity. In fact, they often work against it. The beings that leave worlds behind would understand this deeply, not as an abstract principle, but as lived experience. They would have seen what happens when feedback loops are ignored. They would have experienced the cost of overshoot. That experience would shape culture, not just technology. Culture is often overlooked in these discussions, but it matters more than machinery. A civilization's relationship to its environment is encoded in its values long before it appears in its infrastructure. What is admired, what is discouraged, what is considered success. A culture that celebrates domination will dominate until it collapses. A culture that values balance will behave differently even with the same tools. So what kind of beings leave worlds behind? likely not conquerors, not exploiters, not expansionists in the simplistic sense. They would be long-term thinkers by necessity, not because they were wiser than us by nature, but because survival filtered for that trait. Short-term civilizations do not get the chance to leave quietly. They end loudly or vanish abruptly. Longevity selects for patience. These beings would also need a different relationship with identity. Human societies are deeply invested in legacy, names carved into stone, structures meant to endure, records preserved, memory externalized. But legacy is a human obsession, not a universal requirement. A civilization that does not fear being forgotten would behave very differently. It would not seek permanence in objects. It would not measure success by how long its markers remain visible. Instead, it might measure success by how smoothly it exits. That idea can feel unsettling because it challenges a deeply ingrained human impulse. We want to matter beyond our lifetimes. We want continuity. We want to be remembered. But remembrance is not a planetary value. It is a psychological one. A civilization that outgrew that need would be capable of disappearing without regret. This does not imply emotional coldness or indifference. It implies a different scale of attachment. Attachment to process rather than artifact, to flow rather than fixation. Such beings might see themselves as temporary expressions of a planetary phase, not as its culmination. That perspective naturally leads to humility even in the presence of immense capability. Another important trait would be decentralization. Centralized systems magnify impact. They also magnify failure. Distributed systems dilute both. Nature favors distribution because it allows adaptation without collapse. A civilization aligned with that principle would avoid concentrating power, energy, or infrastructure in ways that destabilize the whole. Its intelligence would be spread across networks rather than housed in singular entities or locations. This has implications for detectability. Distributed intelligence does not leave obvious hubs. It does not create single points that stand out in the record. It blends into background behavior. From the outside, it might not look like intelligence at all. There is also the question of embodiment. We often assume intelligent beings must resemble us in some structural way. Large bodies, durable skeletons, long lifespans. But intelligence does not require any of those things. It requires information processing, memory adaptation, and the ability to influence outcomes. Those functions can be distributed across many forms. A civilization composed of small, short-lived entities could still exhibit long-term intelligence if its organizational structures persisted. In that case, the beings themselves would not fossilize well. Their bodies would leave almost nothing behind. What would persist would be patterns of interaction, environmental modifications that stabilize conditions, subtle shifts in ecosystem behavior. Again, not ruins, not relics, just systems behaving slightly differently than expected. The beings that leave worlds behind would also need to operate on timescales that dwarf individual lifespans. Planning measured in centuries or millennia, rather than years. Decision-making that prioritizes stability over speed. This does not require foresight in the prophetic sense. It requires feedback. Slow systems provide clearer feedback because consequences unfold gradually. Fast systems obscure feedback because effects are delayed. A civilization that slowed itself down would gain clarity at the cost of excitement. That trade-off favors persistence. Another trait worth considering is adaptability without expansion. Humans tend to adapt by expanding into new niches. We spread, we occupy, we modify. That works until it doesn't. An alternative is adaptation through internal change, altering behavior, organization, or metabolism rather than territory. That kind of adaptation reduces external footprint. If a civilization learned to adapt internally rather than externally, its growth phase might end without triggering collapse. It would not need to spread endlessly. It would stabilize and then eventually recede. That recession would not be forced. It would be chosen. Leaving a world behind also implies acceptance of finitude, not just individual mortality, but civilizational mortality. A recognition that no configuration lasts forever and that trying to force permanence creates fragility. A civilization that accepts its own impermanence would not cling to infrastructure indefinitely. It would dismantle what is no longer needed. It would allow systems to wind down. In human terms, This is difficult to imagine because institutions are built around continuity. Governments, economies, cultures all assume indefinite extension. Even when we talk about sustainability, we often mean sustaining ourselves, not sustaining the planet after we are gone. The beings that leave worlds behind would invert that priority. The continuity of the planet would matter more than the continuity of the civilization. That inversion is profound. It suggests a different ethical framework. One where intelligence is accountable to its environment rather than entitled to it. Such beings would likely see themselves as guests rather than owners. Guests do not remodel permanently. They clean up after themselves. They leave the place functional. This metaphor is imperfect, but it captures something important. Ownership implies control. Stewardship implies responsibility. Guests understand temporariness. Another aspect to consider is communication. Humans broadcast. We send signals outward. We announce ourselves. We equate communication with presence. A civilization that did not prioritize broadcasting would be quieter by default. Its signals might be local, transient, or internal. Once it disappeared, nothing would linger. That silence would not indicate secrecy. It would indicate disinterest in being noticed. From our perspective, that kind of civilization is almost invisible. Not because it hides, but because it does not perform. This raises an uncomfortable possibility. The civilizations most likely to be detected are not the most successful ones. They are the ones in unstable phases. Rapid expansion, high energy use, loud signals. If that is true, then silence may correlate with maturity rather than absence. The beings that leave worlds behind may be the ones we are least equipped to notice. There is also the possibility that such beings do not remain biological in the way we expect. Transitioning into forms that operate at different scales or energies would further reduce detectability. However, this does not require exotic speculation. Even within biology, we see transitions that dramatically change visibility. Consider how dominant dinosaurs once were and how completely they vanished from the surface record after extinction. Birds persist, but in forms that look very different. Scale that kind of transformation to intelligence and the continuity becomes difficult to track. The idea of beings leaving worlds behind also forces us to confront a mirror. What kind of beings are we becoming? Are we moving toward louder, more extractive phases or quieter, more integrated ones? That question is not hypothetical. It is active. Our current trajectory suggests we are still early in the process. We are learning limits the hard way. Feedback is arriving faster than expected. Systems are destabilizing. Whether we adapt toward integration or push further into disruption will determine not only our survival but the kind of trace we leave. If we fail to adapt, we will not leave quietly. Our impact will be obvious, sharp, and short-lived, a spike in the record. If we succeed, our later faces may be less visible than our early ones. The most advanced version of human civilization may not look impressive to distant observers at all. That idea reframes ambition. It suggests that the goal is not to leave a mark, but to avoid leaving one that harms what comes next. The beings that leave worlds behind would understand that. They would not equate disappearance with failure. They would see it as completion. Completion does not mean extinction. It means transition into forms that no longer require planetary-scale intervention or into non-existence accepted without panic. From Earth's perspective, both look the same. As this line of thought continues, it does not close the question of whether such beings existed here before us. It sharpens it. It moves away from imagery and toward criteria. If we ever hope to recognize traces of prior intelligence, we must first understand what success looks like at planetary scales. Not dominance, not expansion, but compatibility. That understanding naturally leads into another challenge. If such beings existed and behaved this way, then our usual methods of looking for evidence may be fundamentally mismatched to the task, which raises the next question. If we would not recognize the evidence even if it were present, what does that say about our search, our assumptions, and the possibility that the clearest traces are the ones we are least likely to label as evidence at all? Recognition depends on expectation, and expectation is shaped by experience. That simple fact explains a great deal about why evidence, even if it exists, can remain invisible. We do not see what we are not prepared to see. We do not label something as significant if it does not fit the categories we already have. When it comes to the possibility of a prior civilization on Earth, this limitation becomes central. The problem may not be that there is no evidence, but that whatever evidence exists does not register as such within our current frameworks. Human science is excellent at answering certain kinds of questions. How do rocks form? How do species evolve? How does climate respond to energy input? These questions are built around repeatable processes and physical laws. They assume that most outcomes are the result of unguided interactions. This assumption is not careless, it is practical. It works extraordinarily well, but it also creates blind spots. When intelligence enters the picture, especially intelligence operating over deep time, the signals it leaves behind may not resemble the outputs of blind processes or the outputs of short-term human activity. They may fall into a narrow middle ground that looks natural enough to ignore and artificial enough to classify as coincidence. One reason we would not recognize the evidence is that we expect it to be discrete, an object, a structure, a boundary layer, something you can point to and say this does not belong here. But deep time does not preserve discreteness, it preserves integration. Anything that survives long enough becomes part of the system. A stone tool left on the surface for a few thousand years still looks like a tool. Left for a few million years, it becomes a rock among rocks. Left for 100 million years, it may not exist at all except as dispersed minerals indistinguishable from others. The same applies to larger systems. Roads do not fossilize as roads. Buildings do not fossilize as buildings. Power grids do not fossilize as grids. They disassemble, redistribute, and dissolve into background processes. So if a civilization existed long before us, the most obvious forms of evidence would be the least likely to survive. That immediately biases our search toward the wrong targets. Another reason recognition fails is that we assume evidence must be intentional, a message, a marker, a warning, something left deliberately for future observers. But leaving messages across millions of years is extraordinarily difficult. Even leaving messages across centuries is unreliable. We struggle with this problem ourselves. Nuclear waste warnings are designed to last 10,000 years, and even that timescale feels unmanageable. Languages change, symbols lose meaning, context evaporates. The idea that a civilization could communicate clearly across geological time assumes a level of control over semiotics and preservation that may not be achievable. If no message was intended, then there is nothing to recognize as communication. Only effects remain. Effects are harder to interpret than messages because they do not announce their cause. They require inference. And inference depends on models. Our models of Earth's history are built to explain natural variation. When they encounter something unexpected, the first response is to refine the model, not to introduce a new category of cause. This is sensible. It prevents premature conclusions. But it also means that unusual patterns are absorbed into existing explanations whenever possible. Anomalies become edge cases, outliers become noise. Over time, they are normalized. This process works well when natural causes are sufficient. It works less well if there are rare causes we're not actively considering. Another obstacle to recognition is scale. Human-made systems tend to operate at scales that are easy to see. Cities, roads, mines. These scales match our perception and our instruments. But a civilization operating primarily through small distributed interventions would leave traces below our usual resolution. Imagine a system that adjusts ecosystems incrementally rather than transforming landscapes. It might alter nutrient flows, species interactions, or atmospheric chemistry in small amounts spread over long periods. No single change would stand out. Only the cumulative effect would matter. From our perspective, the cumulative effect would look like a natural baseline. We already see this problem in reverse when studying early life. The earliest biological activity did not leave obvious fossils. It left chemical signatures, isotopic ratios, subtle shifts that required decades of careful study to interpret. Even then, interpretation was contested. If biological life can be hard to recognize in the deep past, intelligence that operates through biology, rather than against it, would be even harder to detect. There is also the issue of Categorization. We divide phenomena into natural and artificial as if the distinction were absolute. But that distinction is contextual. A beaver dam is artificial in the sense that it is built by an organism. Yet it is treated as natural because it arises from biology. A termite mound is not considered a technological artifact even though it regulates temperature and airflow with remarkable efficiency. These examples reveal something important. We already accept that non-human organisms can engineer environments. We do not label their constructions as evidence of intelligence beyond instinct because they fit within our expectations of animal behavior. Now imagine a species whose engineering extended further but still operated through biological or ecological means. At what point would we stop calling it natural and start calling it technological? There is no clear boundary. If prior intelligence took a form that blurred this boundary, we would likely classify its outputs as natural structures. Not because we are careless, but because our categories are limited. Another factor is narrative bias. We prefer stories with beginnings, middles, and ends. We look for turning points, discoveries, moments of realization. But deep time does not produce narrative-friendly evidence. It produces gradients, overlaps, and slow transitions. A civilization that rose and fell without triggering a mass extinction or dramatic climate event would not leave a clean narrative arc in the record. Its presence would be smeared across time. Later, observers would struggle to tell where it began or ended. There is also the problem of uniqueness. We often assume that intelligence leaves unique signatures, but uniqueness is hard to define in complex systems. Many natural processes can produce similar outcomes through different mechanisms. Convergent evolution is one example. Different lineages independently develop similar solutions because the environment favors them. The same could apply to planetary systems. Similar climate trajectories could arise through different combinations of causes. Similar chemical distributions could result from different histories. Without multiple examples to compare, distinguishing intentional influence from natural convergence becomes extremely difficult. This is compounded by the fact that we have only one Earth to study. We lack a control group. We cannot easily say what Earth would look like if intelligence had never existed. We can model, we can simulate. But models are constrained by assumptions. If one of those assumptions is that intelligence arose only once, the model will never test alternatives. This does not mean the assumption is wrong. It means it shapes what we notice. Another reason recognition fails is emotional resistance. The idea that we might not be the first intelligent inhabitants of Earth challenges deeply held narratives about uniqueness and destiny. Even when people do not consciously reject the idea, it will influence how seriously they engage with it. Science prides itself on objectivity, but scientists are human questions that threaten foundational assumptions are approached cautiously, sometimes unconsciously sidelined unless compelling evidence forces attention. In this case, compelling evidence may not exist in a form that demands confrontation. There is also the issue of interdisciplinary gaps. Evidence of prior intelligence, if it exists, would not belong neatly to one field. It would sit at the intersection of geology, biology, chemistry, and system science. No single discipline would claim ownership. As a result, potential clues might fall between categories. Each field might explain a pattern using its own tools without considering alternatives outside its scope. This is not negligence, it is specialization. But specialization comes at the cost of holistic interpretation. We already see this challenge in Earth science more broadly. Integrating climate models with biological, evolution and geological processes is difficult. Adding intelligence as a variable makes it even more complex. Another subtle reason we would not recognize the evidence is that we expect evidence to point backward clearly. We expect it to say this happened because of that. But deep time rarely allows such clarity. Causes and effects are separated by layers of intervening processes. Even if a prior civilization caused a significant change, later natural processes might dominate the signal. The cause would be overshadowed by the consequences of its own consequences. At that point, identifying the original source becomes almost impossible. This is why the idea does not lend itself to discovery announcements. There is unlikely to be a moment when someone finds a definitive artifact and the question is settled. More likely, if the idea ever gains traction, it will do so gradually through shifts in how we interpret familiar data. Recognition may come not as revelation but as reframing. Another important point is that absence itself can be misread. We often treat the lack of certain features as evidence that nothing intervened, but absence can result from depletion rather than non-existence. If a prior civilization used certain resources extensively, those resources might simply be gone or diminished. Later observers would assume they were never abundant. This applies not only to physical resources, but to ecological possibilities. Species that never evolved because niches were previously occupied and then erased would leave no trace of their absence. We cannot miss what we never knew to expect. Recognition also depends on temporal perspective. We study Earth's past with increasing resolution closer to the present. The further back we go, the coarser our view becomes. Fine details are lost. If a civilization existed during a period we can only observe at low resolution, its presence might be smoothed out entirely, like trying to detect individual brushstrokes in a painting viewed from miles away. No amount of closer inspection can recover detail that has already been averaged out. There is also the problem of self-reference. Any evidence we interpret is filtered through our own existence. We are products of Earth's current state. Our methods, questions, and assumptions are shaped by the outcome of whatever happened before. This means we cannot fully step outside the system we are studying. We are trying to reconstruct a history that led to us using tools that depend on that same history. That circularity limits what can be seen. None of this means that evidence definitely exists, and we are missing it. It means that the threshold for recognition is much higher than intuition suggests. Evidence would have to stand out not only against natural variation, but against our expectations, models, and biases. It would need to be both preserved and interpretable. That combination is rare. This is why the idea of a prior civilization remains in a kind of intellectual limbo, not refuted, not supported, simply unresolved. The unresolved nature of the question does not weaken it, it situates it properly, as a thought experiment that probes the limits of inference rather than a claim demanding proof. There is also a lesson here that applies beyond this specific idea. Our inability to recognize certain kinds of evidence is not a flaw. It is a reminder that knowledge is bounded by perspective. We see what our tools allow us to see. We understand what our concepts allow us to frame. As those tools and concepts evolve, what counts as evidence may change. Perhaps the most important reason we would not recognize the evidence is that we expect it to answer the wrong question. We ask, did someone build here? But the more relevant question might be, did something act here in a way that altered long-term planetary behavior? The first question looks for builders, the second looks for influence. Influence is harder to attribute, but easier to hide. As this line of thinking continues, it does not conclude that evidence is present or absent. It simply clarifies why certainty is elusive. It also points forward. If recognition is limited by expectation, then expanding expectation becomes part of inquiry, not by abandoning rigor, but by widening the range of possibilities we're willing to consider. It is a strange thing to consider yourself not as a beginning, but as a continuation, not the first voice in a room, but the next one to speak after a long silence. Thinking of humanity as the second occupant of Earth does not require certainty about who came before. It only requires loosening the assumption that nothing did. Once that assumption relaxes even slightly, our position on this planet starts to feel different, quieter, and more provisional. Second occupants do not arrive to fanfare. They inherit conditions without context. They use what works without knowing why it works. They assume the layout is natural because it is all they have ever known. If something feels stable, they call it baseline. If something feels generous, they call it luck. The history behind those conditions, if it exists, remains invisible. That is what makes the idea unsettling and grounding at the same time. If humanity is the second occupant, then Earth is not a stage built for us, nor a random accident that happened to suit us perfectly. It is a place that has already been lived on, already been shaped, and already been reset into something that looks self-consistent. This does not make us imposters. It makes us participants in a longer sequence. Human cultures are deeply attached to firstness, first discovery, first invention, first intelligence. We celebrate origins because they give structure to identity. Being first implies ownership, destiny, and uniqueness. Being second implies inheritance, limitation, and responsibility. That shift matters. Second occupants do not get to decide the fundamental rules of a place. They adapt to them. They discover constraints rather than define them. They learn what breaks by breaking it. Humanity's history fits this pattern remarkably well. We did not design Earth's climate system. We discovered it by destabilizing it. We did not plan ecological balance. We learned its importance by disrupting it. We did not choose resource limits. We encountered them when growth ran into friction. All of this can be explained without invoking prior intelligence, but viewed through the lens of second occupancy, these experiences take on an additional layer. We're not discovering pristine systems. We're discovering systems that may already be tuned to tolerate only so much interference. Second occupants often mistake inherited resilience for infinite capacity. A house that stands after years of neglect can give the impression that neglect has no cost until one day it does. A forest that regrows after disturbance can seem inexhaustible until recovery slows and then stops. Earth has absorbed extraordinary changes and continued functioning. That resilience is real. But resilience is not the same as invulnerability. It has thresholds. If a prior civilization existed and pushed Earth close to those thresholds before receding, the planet we experience now may already be operating within narrowed margins, not damaged but constrained, stable but sensitive. In that case, humanity would not be testing virgin limits. We would be testing limits that have been tested before. That possibility reframes many modern anxieties: climate sensitivity, biodiversity loss, resource depletion. These may not be novel challenges. They may be recurring ones encountered by any intelligence that reaches a certain level of planetary influence. Being the second occupant would mean that the problems we face are not random. They are structural. They emerge whenever intelligence grows faster than integration. This does not imply determinism. It implies pattern. Patterns are easier to see after repetition, but they do not require repetition to exist. Another implication of second occupancy is humility about knowledge. We often assume that the current state of Earth reflects natural inevitability. That rivers flow where they flow because that is where they must. That ecosystems look the way they do because that is the only way they could. But if Earth has been shaped before, then some of what we call natural may simply be inherited. Not designed for us, not optimized for us, but left behind by processes we did, not witness. This does not mean Earth is artificial. It means Earth has history beyond biology. Second occupants rarely know which features of a place are original and which are remnants. Over time, that distinction loses meaning. What matters is function, not origin. Humanity already lives this way. We build on top of ancient cities. We farm soil altered by previous agriculture. We use landscapes shaped by long-gone societies. Often we do not realize it until evidence surfaces, and even then, it changes little about how we live day to day. Scale that up and the same logic applies planet-wide. Being second also changes how we think about failure. If a prior civilization existed and is gone, its disappearance is not a warning carved into stone. It is a silence, a lack of instruction. That absence forces us to learn independently. Humans often search for guidance from the past, myths, records, ruins. If Earth once hosted intelligence far earlier than us, there is no guidance left in any usable form. That does not mean there was nothing to learn. It means learning cannot come from instruction. It can only come from inference. We infer limits by encountering them. We infer balance by disrupting it. We infer sustainability by approaching collapse and stepping back if we manage to. Second occupants do not get manuals. There's also a psychological dimension to this idea that is easy to overlook. Being first allows for a certain kind of optimism. Everything feels open-ended. The future feels unconstrained. Being second introduces a quiet pressure. If someone came before and didn't last, then longevity becomes a question rather than an assumption. That question does not demand pessimism. It demands attention. It asks whether intelligence naturally burns through its window of influence quickly, or whether longevity requires a transformation in values and behavior. Humans are currently in a phase where power has outpaced wisdom. That imbalance is common in early stages of any system. Whether it resolves or collapses depends on feedback and adaptation. If a prior civilization existed, its fate would not determine ours, but it would contextualize it. We would not be unique in facing these choices. We would be participants in a recurring challenge posed by complex planets to emerging intelligence. Another implication of second occupancy is that we may misinterpret warning signs. We tend to look for dramatic thresholds, tipping points, sudden collapse. But if Earth has already absorbed one civilization and returned to equilibrium, the signs of danger may be subtle rather than catastrophic. Systems that recover slowly can appear stable until they are not. Feedbacks that have already been weakened may not respond the way models predict. This could explain why some planetary responses seem muted while others seem abrupt, not because Earth is unpredictable, but because it has history. That history would not be readable as a narrative. It would be embedded in system behavior. Second occupants also inherit biases. We assume that the way Earth responds to stress now is how it has always responded. But if responses have been altered by prior events, our assumptions may be incomplete. Again, this does not require prior intelligence to be true. It simply shows how the idea fits without breaking known processes. The concept of second occupancy also reshapes the question of stewardship. If we are not the first, then stewardship is not about preserving a pristine world. It is about maintaining a functioning one. A functioning world is not static. It changes, it evolves, but it remains within bounds that allow complexity to persist. If those bounds were discovered before, then the challenge before us is not unprecedented. It is recurrent. There is something quietly sobering about that. It suggests that intelligence is not tested once, but repeatedly, each time under slightly different conditions, each time with the same fundamental constraint, a finite planet. Humanity often frames its story as exceptional. We are different because of culture, language, technology. All of that is true, but those differences may be superficial at planetary scales. At that scale, intelligence looks like energy use, material flow, and system interaction. Species-specific details blur. Second occupants may believe their story is unique. First occupants likely believe the same. That realization is not meant to diminish meaning. It is meant to redirect it. Meaning does not come from novelty alone. It comes from response. How we respond to inherited conditions matters more than whether we were first to encounter them. There is also a question of responsibility that arises naturally here. If Earth has already hosted intelligence once, then it has demonstrated both generosity and indifference. It allowed intelligence to arise. It did not preserve it. The planet does not guarantee continuity. That responsibility falls inward, not outward. No one will intervene. No past civilization will return to guide us. No future intelligence will judge us while we are here. We are accountable only to the systems we depend on. Second occupancy also reframes hope. Hope is often framed as progress without limit. More growth, more reach, more permanence. But if permanence is not guaranteed, hope shifts toward quality rather than duration. Hope becomes the hope of alignment, of learning faster than collapse, of integrating rather than extracting. Those are quieter hopes, but they are more realistic ones. Another subtle shift occurs in how we think about legacy. If we are the second occupant, legacy is not about being remembered forever. It is about leaving conditions that allow something else to arise later. That something else may not be human. It may not be intelligent in our sense. It may not exist at all. But the possibility matters. Legacy becomes environmental rather than cultural. This perspective aligns closely with ecological thinking. Systems persist when waste becomes input. When excess is dampened, when diversity is preserved, whether or not a prior civilization existed, Earth behaves as if it expects this. Humanity as the second occupant also invites restraint in storytelling. We may never know for certain if anyone came before us. That uncertainty is not a flaw. It is appropriate. Some truths are not accessible. Some histories are not recoverable. Acting responsibly does not require full knowledge of the past. It requires attention to the present. If other S came before and left quietly, they did not leave instructions. But they may have left a context, a planet that still works, but only within limits. Those limits are now becoming visible to us. The idea of second occupancy does not conclude anything. It does not demand belief. It does not rewrite science. It simply adjusts perspective. Instead of asking, "Is this our world?" asks, "How do we behave in a world that is older, deeper, and more experienced than we are?" Suppose just for a moment that this were not speculation, but context, not something to be proven tomorrow or argued over endlessly, but simply a background condition of reality. Imagine that it is true that Earth has hosted a technological civilization before us, that it rose, adapted, and eventually faded so completely that only the planet itself remembers, if remembering is even the right word. The immediate question is not who they were or why they left. The more revealing question is what that knowledge would do to us, how it would reshape the way we think, behave, and place ourselves in the long flow of time. The first change would be subtle, but deep. It would alter our sense of arrival. Humans tend to think of themselves as having arrived at something new, a fresh world full of untouched possibility. Even when we acknowledge Earth's age, we still treat our moment as special, in a singular way. We are the ones who figured things out. We are the ones who crossed a threshold. If it were true that someone else crossed that threshold long before us, the feeling of arrival would soften. We would not feel like pioneers stepping onto an empty stage. We would feel more like late-comers entering a space that has already seen a full cycle of activity. That shift alone would change the emotional tone of human ambition. Much of our drive comes from the belief that we are writing the first and most important chapter of a new story. Being first gives urgency to conquest, exploration, and expansion. It frames growth as destiny. But if we were not first, if intelligence has already played out one full arc on this planet, then growth would no longer feel like a mandate. It would feel like a phase, one that has a known end point, even if the details are unclear. This does not remove motivation, it redirects it. Instead of asking how far we can go, we might ask how long we can last. Instead of measuring success, by scale and speed, we might measure it by stability and restraint. That is not a small psychological adjustment. It would run against centuries of cultural momentum built on expansion as proof of progress. Another change would occur in how we interpret risk. Right now, many existential risks are discussed as unprecedented. Climate change, biodiversity collapse, large-scale technological hazards. These are often framed as uniquely human-made problems in a world that was otherwise stable. If it were true that a prior civilization existed and is gone, these risks would no longer feel entirely novel. They would feel like recurring challenges tied to intelligence itself. That does not make them inevitable. It makes them familiar in a deeper sense. Familiarity changes response. When a problem is seen as unprecedented, it can feel overwhelming or abstract. When it is seen as recurrent, it invites pattern recognition. What kinds of behaviors lead to collapse? What kinds of adjustments allow continuation? Even without knowing exactly what happened before, the mere possibility that it has happened would push us to look for structural similarities rather than isolated causes. This would temper our confidence, not in science or reason, but in permanence. We often behave as if our institutions, technologies, and systems are naturally self-sustaining once established. History already challenges that assumption at smaller scales. A prior planetary scale precedent would challenge it at the largest scale possible. Confidence would give way to caution, not paralysis. Another profound change would occur in how we think about legacy. Human societies invest enormous effort into being remembered. Monuments, records, archives, digital preservation. We act as though remembrance is a form of survival. If it were true that an entire civilization could exist and vanish so thoroughly that it leaves no recognizable memory, the value of remembrance would shift. Legacy would stop being about names and artifacts. It would become about conditions. What persists would matter more than who is credited. Clean water, stable climate patterns, resilient ecosystems. These would become the true measures of success because they are the only things that could plausibly outlast us in a meaningful way. This would not make culture irrelevant. It would make culture instrumental rather than banal. Stories, art, and knowledge would still matter, but primarily for how they guide behavior now, not for how long they endure. Another change would touch our sense of exceptionalism. Humans often oscillate between feeling insignificant in a vast universe and feeling uniquely important because of our intelligence. The idea that intelligence may have arisen on Earth before us undermines both extremes. We would not be cosmically unique, but neither would we be meaningless. We would be one instance of a pattern that the planet seems capable of producing under the right conditions. That is a humbling realization, but also a stabilizing one. It places us within a lineage of possibility rather than on a pedestal. That lineage would not be genetic or cultural. It would be functional. Intelligence as a phase Earth can enter given enough time and complexity. This reframing would likely soften the sharp boundary we draw between humanity and nature. Right now, much of our self-image depends on separation. We are the thinkers. Nature is the backdrop. We act upon it. It reacts. If we were not the first intelligent actors here, that boundary would blur. Intelligence would no longer feel like an intrusion into a natural world. It would feel like something the world occasionally produces, uses for a while, and then absorbs back into itself. That perspective would make domination harder to justify. It is one thing to dominate something you see as other. It is another to dominate something you see as your own larger system. Another shift would occur in our relationship to time. Humans are notoriously short-term thinkers, not because we are careless, but because our biology evolved for immediate survival. Even our institutions struggle to plan beyond decades. If it were true that another civilization ran out of time before us, long-term thinking would no longer feel optional. It would feel like a survival trait, rather than a moral preference. This would not magically make us better planners, but it would change the narrative around patience, maintenance, and slow decisioning. These traits are often undervalued because they do not produce rapid, visible results. In a second occupant mindset, they would be reclassified as advanced behaviors rather than conservative ones. Maintenance would gain status. Repair would be seen as progress. Slowing down would not automatically signal failure. There would also be a change in how we think about technological maturity. Today, advanced technology is often associated with increasing abstraction, automation, and scale, bigger networks, faster systems, more integration. If a prior civilization existed and vanished, technological maturity might be redefined as the point at which technology stops expanding its footprint and starts shrinking it. The most advanced phase would not be the most visible one. It would be the least disruptive. This would challenge many assumptions about innovation. Success would no longer be measured by how much a technology changes the world, but by how little it needs to. That idea alone would change research priorities. Energy systems that blend into existing flows would be valued over those that overpower them. Materials that degrade cleanly would be favored over those that persist indefinitely. Systems designed to fail gently would be prioritized over those that aim for uninterrupted operation at all costs. Another subtle change would affect how we talk about responsibility. Right now, responsibility is often framed in terms of future generations of humans. What kind of world are we leaving for our children and their children? If Earth has already hosted intelligence once, this scope of responsibility widens. The question becomes not just what we leave for humans, but what we leave for whatever comes next, whether or not it resembles us. This is not abstract morality. It is practical. A planet pushed beyond certain thresholds may still recover, but recovery could take millions of years. That delay could preclude the emergence of complex life for a very long time. Knowing that intelligence can disappear and take its opportunity window with it would make that cost feel real rather than hypothetical. There would also be a change in how we interpret failure. If we are the second occupant, then failure is not the end of the story. It is part of a longer sequence that does not make failure acceptable. It makes it instructive. This perspective could reduce the paralyzing fear that often accompanies discussions of collapse. Fear tends to produce denial or fatalism. Context produces focus. Instead of asking whether humanity will last forever, the question becomes how well we navigate the phase we're in. Forever is no longer the benchmark. Compatibility is another important if it would occur in how we interpret silence from the past and from elsewhere. Silence would no longer feel like abandonment or emptiness. It would feel like spacing, like intervals between notes in a piece of music too slow to hear all at once. This would likely make us more patient listeners, less desperate for immediate confirmation that we are not alone or unique. The absence of voices would not imply isolation. It would imply that voices are rare and brief relative to the timescales we're dealing with. That patience could change how we approach exploration both of Earth and beyond. Instead of searching for loud signals, we might become more attentive to subtle ones, patterns rather than broadcasts, long-term behaviors rather than momentary spikes. On a personal level, this idea would also change how individuals relate to meaning. Much existential anxiety comes from the pressure to be special, to matter uniquely in a vast universe. If intelligence is recurrent but temporary, meaning no longer comes from uniqueness alone, it comes from participation. Being part of a sequence can be just as meaningful as being the first entry. In some ways, it can be more meaningful because it could arise responsibility without entitlement. This could ease the tension between cosmic insignificance and human importance. We would matter not because we are unprecedented, but because we are present now during a narrow window when our actions have outsized influence. Another effect would be on humility and knowledge. If a prior civilization existed and vanished without leaving clear instructions, then knowing everything becomes an unrealistic goal. Some aspects of the past are irreversible. Some mistakes may only be understood through experience rather than explanation. This acceptance could reduce the tendency to demand absolute certainty before acting. We would not need perfect knowledge of the past to behave responsibly in the present. We would only need to recognize patterns of fragility and resilience. There is also a social dimension to this change. Many conflicts are driven by short-term competition for dominance, resources, and recognition. A second occupant perspective reframes these conflicts as distractions. If the true challenge is long-term compatibility with a planet, then internal division becomes a liability rather than a strategic difference. This does not erase concerning conflict, but it changes which conflicts matter most. The idea would also likely influence how we teach history and science. Earth's story would be framed less as a march toward human arrival and more as a series of experiments in complexity. Humans would be one such experiment, not the end point. This framing would not diminish human achievement, it would place it in context. Context is not reduction, it is grounding. Perhaps the most profound change would be emotional rather than intellectual. There is a certain loneliness in believing you are the first and only intelligence to ever wonder about a place. There is also a certain pressure. If it were true that someone else once wandered here too, that pressure would ease. We would not be alone in having tried. Even if we never know who they were, the idea that the planet has hosted reflection before us creates a quiet companionship across time. Not a connection, not communication, just resonance. That resonance would not tell us what to do. It would simply remind us that intelligence is not guaranteed to last, and that lasting is not the same as succeeding. As this thought settles, it does not demand belief. It does not ask to prove. It asks what kind of people we would become if we allowed it to inform our priorities. Would we become more careful, more patient, more willing to value balance over speed? Would we become less obsessed with being remembered and more concerned with leaving conditions that allow life to continue? Those questions do not need answers yet. They are not conclusions. They are shifts in orientation. And, as orientation shifts, so does the direction of the next question. Not about how this idea changes us internally, but about how it changes how we act outwardly. How we move on a planet that may already have taught this lesson once quietly without leaving a sign, and whether we are capable of learning it in time to avoid becoming just another silent interval in Earth's long, unfinished story. To live gently is not a command, and it is not a slogan. It is a posture, a way of moving through a place when you know, or at least suspect, that it is not entirely yours. The idea of a borrowed world carries that posture naturally. Borrowed things invite care without demanding ownership. They ask for attention rather than control. If Earth is a world we did not originate and may not finish, then living gently becomes less of an ethical ideal and more of a practical response to reality. A borrowed world is not fragile in the everyday sense. Earth has endured asteroid impacts, volcanic winters, and mass extinctions. It will endure whatever happens next, but endurance is not the same as accommodation. The planet can survive almost anything civilizations cannot. Living gently in this context is not about saving Earth. It is about staying compatible with it long enough to remain here meaningfully. That distinction matters because much of the language around environmental responsibility is framed as rescue, save the planet, protect the Earth. These phrases center human agency in a way that can be misleading. The planet does not need protection in the way we do. What needs protection are the narrow conditions under which complex life, including us, can function. If Earth is borrowed, then those conditions are not guaranteed. They are inherited. They exist because countless processes aligned over deep time, possibly more than once. That alignment is not permanent. It can be disrupted slowly or quickly, deliberately or accidentally. Living gently begins with recognizing that alignment, something provisional rather than automatic. This perspective shifts the role of intelligence. Intelligence is often framed as the ability to bend environments to suit needs. On short timescales, that works. On longer ones, it becomes self-defeating. Environments push too far, stop cooperating. Feedback loops tighten. Options narrow. A gentle presence does not mean a passive one. It does not require retreat or stagnation. It requires responsiveness. It requires paying attention to signals before they become alarms. In human terms, living gently is already something we understand at small scales. We know how to live gently in a library, in a hospital, in a shared space. We lower our voices. We move carefully. We adjust behavior based on context. What we struggle with is scaling that behavior to planetary systems where feedback is delayed and consequences are distributed. If Earth is borrowed, then context expands. The library is vast. The hospital is global. The shared space includes future life we will never meet. This does not require moral heroism. It requires calibration. Calibration begins with energy. Energy use is the most basic expression of impact. Every system, biological, AL or technological, runs on energy. The question is not whether to use it, but how fast and from where. Rapid energy use produces rapid change. Slow energy use produces gradual change. Earth systems evolve to handle slow change. They struggle with rapid shifts. Living gently does not mean abandoning energy use. It means aligning energy use with rates the planet can absorb without destabilizing itself. That alignment is not static. It requires constant adjustment as systems respond. A borrowed world does not offer unlimited credit. It offers terms. Another aspect of living gently is material flow. Materials move through Earth's systems whether we guide them or not. Mining, manufacturing, and disposal accelerate those flows dramatically. When acceleration outpaces recycling, accumulation occurs. Accumulation leads to disruption. Natural systems tend towards cycles. Waste becomes input. Excess is redistributed. These cycles are not perfect, but they are robust because they operate continuously. Living gently means designing material systems that behave more like cycles than pipelines. Use, return, reuse. Not because it sounds virtuous, but because linear systems terminate and cycles will persist. This is not an abstract principle. It is a survival strategy. Living gently also changes how we think about scale. Human ambition often equates scale with success. Bigger projects, wider reach, faster rollout. These metrics make sense in competitive contexts. They make less sense in closed systems. A borrowed world is a closed system in most relevant ways. Inputs are limited. Outputs accumulate internally. There is no external sink for excess. In closed systems, success favors fit over dominance. The organisms that persist are not the largest or the fastest. They are the ones whose demands match what the system can supply. That principle applies to civilizations as well. Living gently would likely involve smaller, more distributed systems rather than massive centralized ones. Redundancy rather than efficiency optimized to the edge. Slack built into infrastructure rather than everything running at maximum capacity. From a short-term economic perspective, this can look wasteful. From a long-term planetary perspective, it is stability. Stability is not exciting. It does not generate dramatic narratives, but it allows narratives to continue. A borrowed world also reframes progress. Progress is often imagined as accumulation of capability. More knowledge, more power, more reach. Those things matter, but without direction they become liabilities. In a borrowed context, progress would be measured by how smoothly systems integrate with existing planetary processes. A technology that solves a problem while creating three others is not progress. It is displacement. Living gently would push innovation toward reducing side effects rather than maximizing output, toward technologies that do less harm rather than more good in isolation. This shift does not stifle creativity, it redirects it. There is also a temporal component to living gently that is easy to overlook. Gentleness is not just about magnitude. It is about pace. How quickly changes are introduced matters as much as what those changes are. Rapid transitions strain adaptive capacity. Even beneficial changes can be destabilizing if introduced too fast. Ecosystems, economies, and cultures all need time to adjust. Living gently would therefore prioritize gradualism where possible. Not because speed is bad, but because shock has costs. This idea often meets resistance because it feels incompatible with urgency. NC. Climate change, biodiversity loss, and other challenges feel immediate. The instinct is to act quickly and decisively. Urgency and gentleness are not opposites. Urgency determines direction. Gentleness determines method. You can move decisively without being reckless. You can act quickly without overwhelming systems. The difference lies in feedback awareness. A borrowed world demands attention to feedback, not just whether something works, but how the system responds. Living gently also alters how we think about ownership. Ownership implies rights without limits. Borrowing implies responsibility with conditions. Modern societies are built on strong notions of ownership: land ownership, resource ownership, intellectual ownership. These frameworks are useful for organizing human interaction, but they can obscure planetary realities. No one owns the atmosphere. No one owns ocean currents. No one owns the climate system. Treating these as commodities rather than shared conditions leads to misalignment. Living gently would require acknowledging that some systems cannot be owned without being damaged. They can only be stewarded temporarily. This does not eliminate property or make it tease, it contextualizes them. It places boundaries around what can be treated as an asset without eroding the asset itself. Another change that comes with living gently is how we define success across generations. Short-term success often undermines long-term viability. Decisions that maximize benefit now can reduce options later. A borrowed world perspective encourages thinking in handoffs rather than endpoints. What condition are we passing forward? What options remain available? What thresholds have we avoided crossing? This kind of thinking already exists in some indigenous cultures where decisions are evaluated based on their impact several generations ahead. That approach is not mystical. It is pragmatic in systems where continuity matters. Living gently would elevate this kind of thinking from cultural tradition to civilizational necessity. There is also a psychological shift involved. Gentleness requires letting go of the need to dominate narratives. Humans like to see themselves as heroes, saviors, or masters. A borrowed world does not need heroes. It needs caretakers. Caretaking is often undervalued because it is repetitive, unglamorous, and ongoing. It does not culminate in victory. It sustains conditions. If Earth has already hosted intelligence once and then absorbed it, caretaking may be the most advanced role available to intelligence at planetary scales. This does not mean renouncing exploration or curiosity. It means orienting them toward understanding limits rather than escaping them. Living gently also affects how we relate to uncertainty. We may never know whether a prior civilization existed. That uncertainty does not weaken the argument for gentleness. It strengthens it. If we knew with certainty that we were first and alone, we might gamble more aggressively. If we knew with certainty that others failed before us, we might become fatalistic. Uncertainty keeps responsibility alive without closing options. A borrowed world with unknown history invites caution without despair. There is also an emotional layer to gentleness that is worth acknowledging. Gentleness is often associated with softness, vulnerability, or weakness. In reality, it requires strength. It requires restraint in the presence of power. Humans now possess unprecedented power to alter Earth's systems quickly. Choosing not to use that power indiscriminately is not weakness. It is maturity. If prior intelligence existed and learned this lesson, it may have learned it too late or just in time. We do not know, but the lesson itself remains available. Living gently would also reshape our relationship with technology. Instead of asking what technology allows us to do, we would ask what technology allows the planet to continue doing. That subtle shift changes priorities. Technologies that reduce strain become more valuable than those that increase reach. Maintenance becomes innovation, optimization becomes adaptation. This is not anti-technology. It is post-naive technology. A borrowed world also reframes endings. Endings are often feared because they feel like failure. But in natural systems, endings are transitions. Leaves fall, species go extinct, new forms arise. Living gently does not guarantee continuity forever. Nothing does. It maximizes the chance that when transitions occur, they are not catastrophic. If humanity eventually leaves Earth, whether through extinction, transformation, or migration, the manner of departure will matter. A gentle departure leaves options open. A violent one closes them. That possibility adds weight to present choices with, without turning them into moral absolutes. Living gently also changes how we view scale beyond Earth. If we ever expand beyond this planet, the borrowed world mindset would still apply. Other worlds would not be blank slates. They would be systems with their own histories and constraints. Exporting extractive habits outward would not solve the underlying problem. It would repeat it. A civilization capable of living gently on one planet would be better equipped to interact responsibly elsewhere. A civilization that cannot do so here would likely struggle anywhere. This is another reason why Earth matters so much. It is not just our home, it is our training ground. There is a quiet realism in this perspective. It does not promise salvation. It does not guarantee success. It simply aligns behavior with conditions. Gentleness does not eliminate risk. It reduces unnecessary risk. As this idea settles, it becomes less about whether Earth is truly borrowed and more about how the assumption of borrowing changes behavior. Acting as if something is borrowed tends to produce better outcomes than acting as if it is owned outright, especially when replacement is impossible. You take fewer shortcuts. You pay attention to where. You consider consequences beyond immediate use. Earth is not replaceable. That fact alone justifies borrowed behavior, regardless of history. If others came before us and left quietly, they may not have intended to teach us anything, but their absence, combined with the planet's continued habitability, creates a context that speaks without words. It suggests that loud phases pass, quiet phases endure, compatibility outlasts dominance. Living gently on a borrowed world is not about guilt or fear. It is about proportion. Knowing how much is enough, knowing when to stop, knowing when maintenance matters more than expansion. Those are not easy judgments. They require ongoing adjustment. They will never be final. And that is fitting because this idea itself does not end here. It does not resolve into a conclusion or a moral. It simply leaves us positioned differently, standing on the same ground as before, but with a slightly altered sense of weight and time. The planet beneath us remains ancient and active. Whatever its full history holds, it continues forward without pause. Our presence is one interval within that motion. Living gently does not mean stepping aside. It means stepping carefully, aware that the ground has been walked before and that it will be walked again. Whether or not anyone remembers our names, as long as we leave it capable of being walked at all.